Okay, welcome everybody. I am Shel Lalji, and it is my absolute honor and privilege to welcome you to day 3, Neurotechnology afternoon with BCI experts and the ALS community. And I want to really stress that we're here for the community. We're here for taking care of all the people in the ALS world who continue to inspire us on a daily basis. I'm so excited to welcome you to today's session on brain-computer interface. And again, before we start, I'd like to take a moment to honor all of our heroes, the people who are living with ALS, their families, and their caregivers. We've heard from several of you over the last 3 days of this incredible conference, and all of us organizers feel very strongly that you are the reason we're here, and we really want to hear your perspectives. So please do continue to send your comments and your questions as this session goes underway. Today in our BCI session, it's all about finding solutions for the real people dealing with this devastating disease. I'd like to give a shout out to my incredible husband, Dr. Shel Lalji, who, like thousands of other pals, has been fighting valiantly since his diagnosis 6 years ago in 2017 at the age of 51 years. Before diagnosis, Ayaz was a practicing dentist and entrepreneur. Most important roles that he played were of a doting husband and a loving father of our 2 beautiful children. Unfortunately, due to all that ALS has taken away, he is now nonverbal. And also from the impact even on his ocular muscles, Ayaz is unable to communicate even through technology. You will hear a bit more about his personal journey and our struggles later on today. Ayaz, like all the other pals, continue to be our inspiration. We as a family, along with a lot of you, have gone through each one of these stages. What we do understand firsthand as a family is that each person living with ALS deserves understanding, compassion, independence, dignity, respect, and an opportunity for connection. Connection with their loved ones, connection with their own purpose, and connection with hope for a better future. And in Steve Gleason's words, and we heard a lot from his foundation and Blair today, most of what ALS takes away, technology can give back. And that's what we're going to be talking about today. Within a year of Ayaz's diagnosis, we as a family decided that we were going to be a part of the solution to the challenges that are faced by thousands of pals who have suffered in silence for literally nearly a century. To that end, we formed our foundation, ALS Heroes, with a 3-tiered approach that were all very important to us: to promote research in the field of repair and regeneration for people living with ALS to actually regain lost function. It is going to be a reality, and it already is underway. To improve quality of life by collaborating with other incredible organizations, and to bring innovation and technology to improve daily living for pals while enhancing mobility and communication. This focus on neurotechnology and BCI is a very important part of that mission. Our foundation believes strongly in collaboration, not reinvention. To that end, this Neurotech Day is one of the many endeavors of that collaboration with ALS ONE, Mass General, as well as Everything ALS, and the Gleason Foundation. This morning, we heard a great deal about the role of AI and digital biomarkers, as we all agree, while the search continues for cures that prevent or reverse the course of ALS, people with ALS deserve to live the best life possible. And a strong part of that is the ability to communicate and the ability to move. This is what the field of brain-computer interfaces, or BCIs, is promising. The idea of BCI sounds simple. If the person wants to move their hand and the brain signals associated with that intent to move can be detected, then a computer could convert those signals into the control of a cursor on a computer screen, or an assistive robotic arm, or maybe back toward the control of the person's own arm and hand. And as we've seen this year, BCIs can even convert the intention to speak back into speech. It sounds like science fiction, but it's already happening. Last year at this conference, we focused on the entry of several companies who are building implanted BCIs and doing the work that we all hope will demonstrate the safety and efficacy to bring such incredible technologies to market. In a few minutes, we'll start today's session with, first and foremost, an insight into the life of people living with ALS and why BCI can be such a game changer for the actual people and the human beings that have to deal with this on a daily basis. This will be addressed by Shel Lalji. We wanted to be sure to shed light on real people with real stories. We will also have a very special presentation from an incredible IBCI clinical trial participant, Pat Bennett. Following Zoe this afternoon, we will focus on the academic and nonprofit researchers who are leading the way in creating breakthroughs in BCI science. We will have the privilege and the excitement to hear from people like Dr. Brian Dekleva from the University of Pittsburgh, Dr. Jonah Zimmerman from the Wyss Center in Geneva, Dr. Mariska van Steensel from Utrecht Medical Center, Dr. Nathan Krohn from Johns Hopkins, Dr. David Moses from UCSF, and Dr. Dan Rubin from Mass General. We will then take a brief break, and then we will be joined by some of our titans of the implanted BCI industry, Dr. Florian Sulzbacher from BlackRock Neurotech, Kurt Hagstrom from Synchron, Dr. Matt Engel from Paradromics, and Michael Mager from Precision. We've invited these four to pepper our academics with their questions and their perspectives. We'll then hear some responses from our academics in a roundtable discussion, and then we will open it up for Q&As from the audience. And once again, I really, really encourage you, if you're from the ALS community, if you're a person living with ALS or a caregiver or a loved one, please do send in your questions and comments, as this is all about you and what we're trying to do for you. Before I introduce our moderator, I'll provide a brief introduction to BCIs to set the stage for this afternoon's discussion. While there are many different kinds of BCIs, they're all built from three different components: a neural sensor, a decoder, and an assistive technology. For people with ALS who are losing the ability to move their hands or the ability to speak, BCIs will first detect the intent to move one's hand or the intent to speak. The brain activity that is associated with that intended movement or speech can be recorded in different ways, which I'll mention in a moment. The brain activity is then decoded by a computer that takes those neural signals and converts it into the control of a communication or a mobility technology. For example, it could be a tablet computer or a smart home or any other useful assistive device, or a speech-to-text application that converts the user's intended speech into text on a computer screen or computer-generated speech. There are a lot of different kinds of BCIs, but we can really only talk about a few of them today, and we will try our best to do so. The presenters will be focusing on technologies that are particularly exciting because they record from inside the skull, either in the brain or on the brain, next to or close to the brain signals that contain the most information. So action potentials from individual neurons, local field potentials from groups of neurons, or the field potentials from the combined activities of larger groups of neurons. These implanted technologies have both incredible potential and unique challenges in getting to market, which is why we focused on them today. We all believe that ALS is a devastating illness, but we are optimistic that behind the deepest wound is the doorway to the greatest gift. We hope BCI is one of those greatest gifts. Once again, here's a slide of all our BCI speakers today. In the interest of saving time, we'll move swiftly from one speaker to the next without reciting their credentials, but they are all listed in the speaker guide, which we really encourage you to look at because we have some incredible speakers today here. And it is now my pleasure to hand things over to our moderator for the session, one of the world's leading experts on BCIs, Dr. Leigh Hochberg. For nearly 20 years, Dr. Hochberg has helped to design and then lead the incredible BrainGate clinical trials, which have been responsible for some of the most amazing breakthroughs in BCI research. Leigh also knows how to create and sustain powerful and productive scientific and clinical collaborations, bringing together stakeholders who are focused on restoring function for people with ALS and other forms of paralysis. Okay. Leigh, so I'm handing it over to you.
No, this is great. So, Jerry, if I may jump.
Thank you, Shel, so much for that kind introduction, and really for such a wonderful introduction to today's session. Good afternoon or good morning, everyone. It is great to have you on today's really exciting session on brain-computer interfaces. Just as Shel was describing, our agenda for today is to hear first from somebody who I will introduce in just a moment. We will then hear in a really rapid succession from some of the true leaders in academic neuroscience and the development of brain-computer interfaces from the academic and nonprofit realms. We will then hear from Pat Bennett, who I will reintroduce just before she presents. That'll be followed by a break, and then we will be having a question and answer period, two of them, in fact, one that will be led by some of our titans of industry, that is representatives and leadership from the companies that are developing implanted brain-computer interfaces. And then for what I hope will be at least the last 45 minutes or so, will be what I really expect to be a wide open and exciting Q&A, where we are really interested in hearing from everybody who is online today, from pals, from the care partners, people with ALS, and from others across the community. So part of my job is to try to keep us on time today. We'll see how that goes. The biggest test is that of my academic colleagues who have been restricted to 9 minutes each. That is a challenge, as I think everybody here can appreciate, but I think we can do it. So with that, I do want to get us started. And it is a real pleasure for me to introduce the woman who's going to kick us off today, who is Zoe Lalji. Zoe is a senior at the University of Texas at Austin, who's studying neuroscience and entrepreneurship on a pre-med track. Her passion for neuroscience began, as you were just hearing, when her father was diagnosed with ALS in 2017. And since then, she's been constantly searching for ways to improve his quality of life and expand his avenues of connection with the world around him. Driven by this passion, Zoe's not only given a compelling TEDx talk at the age of 17, which I encourage everyone to look for and listen to, but she's also earned recognition as one of this year's Austin Innovators of 25 under 25. She's also the founder of Valor, which is a really pioneering company that's dedicated to making virtual reality accessible to people with ALS and other populations of people with physical disability. The aim is to empower with autonomy through immersive experiences and novel activities that transcend physical limitations. Zoe's journey is a testament to her commitment to bridging the gap between technology and compassionate care for those facing significant challenges from physical disability. I've had the great pleasure of meeting Zoe on several occasions, and I'm really excited for her to kick off this afternoon's session on brain-computer interfaces. Zoe?
Thank you so much for that intro, Leigh, and thank you, Mom, for that great start to our day and that wonderful summary for BCIs. So hello, everyone. Welcome to day 3. I'm really excited to hear from all of our speakers today, and I'd love to just kick us off with sort of a perspective from an ALS family to kind of ground the day in exactly what my mom said, because we're all here for the pals and the families and their families, and to really focus on that impact. So first, I want to take everyone back 5 years ago. This is a picture of my dad in 2017. He was a self-made entrepreneur and owned 9 dental practices. He loved staying active and went for a run every morning. He told way too many dad jokes and always went overboard for Halloween, as you can see by these pictures. He gave the best advice and the tightest bear hugs, and he never missed the chance to tell us that he loved us. These things, among so many other little things, are what made my dad who he was and the man that raised me. This is my dad now. Some people can point to a day in their life and say that was when it all changed. For me and my family, that day was September 5th, 2017, and it all began with a twitch. My dad woke up that morning with fasciculations all over his body, and 3 months later, he was diagnosed with ALS. I still find it so bizarre that just 3 letters have had the power to change our lives so completely. From that day on, he could no longer go running every morning. He could no longer run his 9 dental practices. He could no longer tell his silly dad jokes or make snarky comments. He could never again give us his famous advice or tell us that he loves us or that he's proud of us. This is the reality for the 450,000 people living with ALS around the world. But I believe that BCI has the power to return some of these things back to PALS and their families. My dad's progression was uncharacteristically rapid at the beginning, to the point where he was diagnosed in November, was in a wheelchair by January, and lost his voice in May. But for us, the worst part was the loss of his voice, because with it went small, discrete things about his personality that made him who he was and the man that we loved. 75% of PALS will ultimately require some form of alternative communication. But for many of these PALS, the devices fall short. Here are some of the available options for PALS that are demonstrated to them when they are first diagnosed. The eye gaze is most common because the eyes are widely unaffected at the beginning of the progression, and this device can convey about 10 words per minute, but this is far off from normal communication, which lies at about 150 words per minute. And I believe that BCI has the power to bridge this gap. Touchscreen and switches are some other options that are presented to PALS who are mostly early stages that may have control over their voluntary movements, and some bulbar onset PALS that may retain this control into the end stages. And for example, you can see Stephen Hawking here, who maintained control of his cheek until very late in his progression and was able to use a cheek switch to communicate. So as I mentioned, except for early stage ALS, as well as some cases of bulbar onset, eye gaze is the most viable option. So if we have eye gaze, why do we need BCI? This is because, contrary to popular belief, 70% of PALS found in this study were shown to have at least one ocular symptom. And for these PALS, all that's left is the use of a letterboard.
Third. And
here I've demonstrated a video on how that works.
Fourth. O. Okay, O. First. Second. Third. Fourth. U. V. V. Okay. First. Second. Third. Second. First row. Second. Third. Fourth. 5. Y. Honey, is it love you?
This video breaks my heart every time I watch it, because not only is a letterboard extremely inefficient, it's also frustrating and time-consuming for PALS and their caregivers. And often PALS have to be extremely selective about what they're able to say and convey to their loved ones, often neglecting even some of their basic needs. And the harsh reality is that some PALS, including my dad, aren't even able to use a letterboard. For PALS like this, BCI would mean the difference between complete isolation and being able to have their needs met again, and being able to connect with their loved ones again. The impact on quality of life is unfathomable. After watching my father slowly lose his ability to communicate, I've realized the immense value in words. We speak approximately 7,000 words a day, 2.5 million words a year, 200 million words a lifetime, but we never realize how precious these words are unless they're taken from us. I would give anything to hear my dad tell me that he loves me again. And BCI has the capacity to return these valuable words to PALs and their families. The chance to not only express their needs, but also reconnect with their identities and their loved ones. This would mean the world for my dad, and for my family, it would be getting to hear his advice again, getting to hear his opinion on things, hearing him crack dad jokes and call us silly nicknames again, hearing him tell us that he was proud of us and that he loves us, and so much more. It would give us back so much of my dad that we thought we lost. BCI also has the huge potential to improve the quality of life of caregivers. Caregivers are often severely overlooked by themselves and others. And as a result, caregiver fatigue can arise from constantly looking to better the lives of your loved one and often neglecting your own in the process. Caregivers, as a result, can report high levels of depression, sleep deprivation, and back pain. Here I've outlined some of the biggest needs that I feel that BCI can help address for caregivers. Much of the caregiver stress comes from providing quality care and being able to fully understand the needs of their loved ones without them being able to communicate it. BCI would allow for this communication to come back without the caregivers having to infer and constantly intuit what the patient would want. In addition to caring for their loved one, caregivers feel this loss of connection, and giving that back would mean a severe decrease in emotional distress as well as depression. Through BCI, caregivers could also receive some much needed feedback and reassurance from their loved one, telling them that what they're doing is good and working, and just getting that appreciation from their loved one. With the emergence of BCI comes a whole world of therapeutic benefits, including improved communication, which would provide a greater connection between caregivers and PALs, as well as reduced feelings of isolation for PALs. This would also include increased appreciation and validation for the caregiver and reduced levels of caregiver fatigue and depression. Until there's a cure, Steve Gleason says that technology is the cure. And I truly believe that BCI can be a part of this. Thank you.
Thank you so much, Zoe. You and your family are so inspiring to all of us, and that really is I can't think of a more perfect way to start off today's session. Everything you just said is the reason that all of us on today's panel are doing the work that we do, whether it be in academia or in industry. And I just want to thank you for your incredible words and for setting us off in exactly the right direction as we begin today's symposium. So with that, for the next handful of presenters, I will not be quite so lengthy in introducing them. Shel did a great job in mentioning everybody before we started, and so I'm going to mention a person's name and where they're from, and we're going to continue. And remarkably, we are only about 63 seconds beyond where we're supposed to be at this point, so we're actually doing all right. So keep hoping to keep that streak. It's my real privilege to introduce Brian Dekleva, who is a research scientist at the University of Pittsburgh Rehab Engineering Laboratories. Brian, it's all yours.
Thank you. On the back of that incredibly moving talk, I wish I had a speech prosthesis talk prepared, but that's not quite what we do. So I'm just going to jump into the efforts that our group has been making towards motor decoding. So motor BCI, which is the controlling computer cursor type of thing. So I'm not going to get too much into this because it's already been introduced, but what we do is we work with participants who have spinal cord injury with similar motor deficits to many people with ALS. And so we're recording intracortically from the these electrodes implanted into the brain. And we're asking the participants to attempt to move their limbs in accordance with something that's presented with them on a screen, like a computer cursor moving in a direction and clicking and unclicking. And they're attempting these movements, and then we're trying to tie together what is happening on the screen that they're observing and attempting with the neural activity that we're recording, which I'm kind of showing here below as in a raster plot, where each dot is kind of the activity of a single channel that we're recording from. And so really, there's been a lot of success over the years of these types of cursor control decoders. And I'd say that one of the big problems for BCI, there's a lot of problems for BCI, or maybe not problems, but challenges. Some of them are more straightforward and very technical in the hardware, and actually having implanted systems that can stick around for a long time and give you good signals. But there's also a problem once you actually have recordings and you're doing these types of tasks. The big problem that we've seen is that there's this enormous range of motor behaviors that people are capable of. And when we calibrate a decoder, we're exploring a very, very small piece of this entire range. And so the big problem is in getting these systems to generalize properly across a whole bunch of different situations. So can the decoder that you trained in this small session, can it be used for a whole bunch of different things throughout the day, as things about your body change, as your attention changes, as your fatigue and all these kinds of things? They seem to affect the control, and we'd like to find a way around that and to provide really generalizable control that sticks around for a long time. So how do we do that? We could just ask ChatGPT to do it for us and figure out the best way to do it. That's a little cheeky way of saying that there is a big data approach that you could take, where you just collect a lot of data from people using BCIs in all kinds of different situations. Then hopefully you can find some kind of stable approach within that you can leverage to have something that is generalizable. However, the approach that our lab is generally taking is to try to first understand how the cortex is trying to control the movement, and then develop algorithms according to that, to try to match on the receiving end what the brain is trying to send out. So I'm going to first talk about efforts in this direction for cursor click decoding. So again, we provide this we do this calibration set where the participants are following along and attempting to click and unclick a cursor as they move it around on a screen. And we record the neural activity. And the neural activity you can think of, or we often think of as these, in terms of their correlation patterns. So these large populations of neurons are activated in different in different patterns. And these can be explained as these neural modes. So you have different dimensions that express different types of activity as you perform a task. And so when we look at these neural modes, this is like a low dimensional representation of what the enormous population is doing. You can see some kind of relationship to the task, but we found that if we do some kind of clever rotating of this space and just looking at it from a different angle, we can actually simplify the problem quite a bit. So we take a slightly different view of this population activity, and now we start to see something that perhaps makes a little bit more sense, or we can make sense of, right? So now we can see that during this, while people are attempting to click this cursor, which is really just they're attempting to squeeze their hand, we see a component that looks a lot like just that, just the click and unclick of the cursor. And we also see these components that correspond to the onset of the click or the offset completely separately. Okay, so now we're getting close to kind of understanding what the building blocks are of this grasp control. And so maybe we can leverage that to improve the control of a BCI. So what are the different decoding approaches you could use? Well, the one that, as far as we could tell, was the only one really was used is the sensible approach, was to try to take the neural activity that you observe when the person is not squeezing their hand and compare it to the activity that you see when they are squeezing their hand, and then build a classifier to try to turn on and off the click. But alternatively, we thought, well, what if we use these other components that occur at the transition points to drive this behavior instead? And so that's what we did, and we tested the two against each other in this task where the goal was to reach out to this little smiley and bring him back home to the center. And on the left is the approach that existed before, which is really good at pointing and clicking and just making discrete clicks, but it seems to struggle when you go add in translation and have people try to click and drag something back. And that click and drag functionality is really important for a lot of everyday use applications that people want to use their BCI for. And so we found that this, by just kind of looking a little deeper into the neural activity and trying to figure out what the components are, we were able to find a way that actually worked a little bit better or significantly better for providing this type of control. And of course, it's not very important that people are able to play this little laboratory game, but the important part is that it really translated into real world use. So here are some videos of our participant playing solitaire using this BCI, playing a video game that he was interested in, and producing digital art, which has actually become a big part of his life. And so we're getting to the point where the advances that we're making in control are actually significantly contributing to quality of life outside of the laboratory setting, which I think is everyone's goal. One other little, I know I have a minute left or so, and I don't want Leigh to yell at me, but I'll just quickly touch on one other arm of research that we're working on, which is decoding now individual fingers rather than just whole hand grasp. So we're going to provide a cue of which finger we want the participant to try to press. And then we're again going to try to build a map and decode when the person is just using it in real world use. So we found that when people are attempting to press different fingers, we have a combination of different types of signals in the brain. So there's some non-specific signals. Each line here is just a different finger that the participant is trying to press. And there are some dimensions of the neural activity, some ways of viewing it where it looks very similar. And we see these same kind of onset, hold, and offset components that we see for whole hand grasp. But then another view of the neural activity, we see this separation into the different fingers. So we kind of took our decoding approach from before, and we have expanded it now into incorporating different fingers. And if I play this video on the left, you can see this is the person using the decoder in real time. So the button lights up in white, indicating which finger to press, and it fills in when the decoder has decoded the participant's intent. So you can see he's quite fast at using it. It's pretty accurate. And on the right, you see a representation of the neural state. This is the activity. And initially, we had a view that was separating by finger, and then we turn it and we see that these other views of the activity that really separate between the onset and offset of the intent. So hopefully these both demonstrate that by kind of understanding what the core computations and signals that exist in motor cortex about motor control, we can use those to create generalizable and stable decoders for real world use. So thank you for listening, and thank you to all of the collaborators. I think I went like 10 seconds over, but hopefully that's okay. I won't get a nasty email. So thank you very much.
Thank you, Brian, for that great presentation. And whether it's fear of yelling or emails, if it's working, and we're on time. So that was great. And thanks for a great overview of the work that you and the team at University of Pittsburgh are doing. With that, glad to hand over to Jonas Zimmerman, who's a senior neuroscientist at the Wyss Center in Geneva.
Hi, thank you so much for giving me the opportunity to present our work at the Wyss Center. Thank you, Zoe, for this really inspirational talk. First of all, I can advance the slide. Yes, 2 words about the Wyss Center, who we are. We are a not-for-profit that was funded by a very generous gift by Hans-Jörg Wyss in Geneva. We're a technology organization, about 70 strong, with an expertise in neuroengineering. We focus on implantable device technology. We collaborate locally and internationally with academics, startups, and industrial partners. And as I said, we're located in Geneva, in Switzerland. Let me start with a patient story. that so this is a patient, Felix, in Germany, whom we worked with. In 2015, in August, he was diagnosed with ALS at only 30 years old. Half a year later, he could not walk or talk anymore. Yet another half a year later, he was artificially ventilated, and he started to use an eye tracker for communication. It took only a year until he could not use that eye tracker anymore because his eye movement was not steady enough. So he starts using slow eye movements for yes and no communication. In February 2018, he started to work in a BCI, EEG-based BCI research project that was led by Niels Bierbaumer from Tübingen University, and participated regularly in research sessions. It came up that he was likely to lose his ability to communicate, and he wanted to participate in research, both to help other people with ALS and, of course, to delay the loss of communication as far as possible. So we started to plan for a UTA array, a microelectrode array implantation in 2018. Finally, in March 2019, we could implant him. By that time, he had already lost any means of communication through EEG or eye movements. It took a few months, but for about 2 years, Felix was able to use a speller, even partially independent. On average, when the system worked for him, he could communicate with about 1.1 characters per minute. Not very slow, but if the alternative is no communication at all, it's an infinite amount. And so I just want to express, there's a lot that resonated in the experience that we had working with Felix and the experience that you relayed. So Felix also had vision problems. He could not focus on a screen. Everything we did was through an auditory interface, and we used neurofeedback as the way. So essentially, whenever we detected higher neural activity from those electrode arrays in his motor cortex, we increased the frequency of a tone. When the activity went down, we decreased the frequency of a tone. And then we could interpret higher frequency tones as yes and lower frequency tones as no's. And we were using the same letterboard scheme that he'd used, while he could still use his eyes and that he'd memorized for communication. What you see on the left of the screen is essentially the researcher's view. And I'm going to play a short video. It's in German. Oh, did I share with sound?
We're not hearing it yet. So if you want to,
yes, yeah,
go ahead.
I need to reshare it. Just
Ja. En. Nein. Es. Nein. Nein. Oh. Oh. Ja.
So this was an example of Felix spelling just one letter essentially. It was painfully slow, but it was a way to communicate for him. And if you can imagine, it took about 3 months for him until he could use the BCI to communicate. The first thing that he said was he was asking his caregivers to turn him on his side because he had a sore on his back. Can you imagine not being able to express that need? But what was very touching was Felix was using the communication system to communicate with his little son, who was just a few years old at the time that he was using the system to watch movies and to connect with him. And of course, he connected with his wife. Let's see. No. This is a calendar view of how Felix was using the system. All those gray squares represent a day on which we used the system with him. Light gray is we were not able to run a speller system at all because communication did not work very well. The gray squares represent days on which the neurofeedback method worked and worked pretty well. However, moving on to Speller, Felix could not actually communicate. I think that's touching on some of the issues that Brian mentioned just a minute ago. Blue are days on which Felix was able to actually communicate. So it's about 25% of the days that we ran the system after the first time that he communicated that he could actually spell. We had COVID in the intervening period, so at some point we had to switch to remote sessions, which worked surprisingly well. The family were really pushing on using the system on their own, so we were frantically working on an independent system for them to use. At the beginning of 2021, they started to use that, but we also saw that Felix's ability to control the communication system declined, which is partially due to a decay of the electrodes themselves and the connector, but also potentially changes in Felix's cognitive abilities. We're not 100% sure about that. Unfortunately, then after 3 years, we did not have any communication at all, so we stopped using the system. The family stopped using the system. So in parallel at the V Center, we've been also working on implantable BCI technology that we develop our own. Our main goals are to focus on the safety for BCI users. We want to lower the infection risk, want to lower the risk of electrodes causing brain damage, lower the risk from surgical procedures, increase the reliability and stability of the interface, the algorithms, the software, and of course, improve the usability for caregivers and families so they can spend time interacting with their loved ones rather than setting up system and working with calibration routines and fixing things that don't work. So plug-in procedures and unsupervised use are very important. We developed a fully implantable technology. We call it Ability. I'm not going to spend too much time on technical details. It's a 128 channel device. We support both subdural ECOG grids and Utah arrays. By sampling rate, we're in preclinical trials right now. So we've implanted sheep. And I want to conclude by mentioning one clinical project that we're working on right now. It's called Intercom, and Mariska from Utrecht is here today, is heavily involved. Here we want to bring the BCI system to patients' home for computer control and brain-to-speech, brain-machine interface for independent home use. Thank you.
Thank you very much, Jonas, for that great presentation and an update from the V Center in Geneva. It's now my pleasure to, what was a perfect segue. I'd like to say that we planned it that way, but Jonas just mentioned our next speaker, who's Mariska van Steensel, assistant professor at University Medical Center at Utrecht, and also the current president of the BCI Society. Mariska, it's all yours.
Thank you. I hope you can share my screen. I think it's very nice to be able to continue the story of Jonas related to real-world application of implanted BCIs for people with ALS. I will be speaking about the atrial neuroprosthesis study, which we have ran in our lab for the past 10 years. And this device is kind of an early generation BCI, implanted BCI, that relies on a limited number of electrodes that are placed on top of the cortical surface and that are connected to wires and then to an implanted amplifier transmitter device. So it has specific limitations that allow us to only use the signal from one electrode pair at a time. But still, I think we have some nice results. We implanted 3 participants with this device, 2 with ALS and 1 with a brainstem stroke. And today I'll be only speaking about the first participant, the one who had late-stage ALS. We accomplished 3 different functionalities with a signal of one single electrode pair, which I will go through sequentially. She could use it to spell words, to call the caregiver, but also to do that during the night. So for spelling words, she used a brain click or a click signal. And she accomplished that by briefly trying to move her hand, which then generated changes in the brain signals in the sensory motor cortex. And whenever those signals were high enough and above a certain threshold for a specific amount of time, the signal would output a brain click that she could then use to select words and sentences on commercially available communication software, which was set to switch scanning mode, which means basically that the red highlighting moves automatically from top to bottom and from left to right. And whenever she wanted to select a field that was highlighted, she would move her hand to quickly select that letter or word. With the signal from the same electrode pair, because of the limitations of the device, we did not have any other options. She was able to produce an independent co-caregiver signal. We instructed her to use more of a long-term hand movement, attempted hand movement for that. So whenever she tried to move her hand for 7 seconds in a row, she would generate this very wide peak in the control signal. And we had a specific decoder that would detect this peak and which would then generate a pop-up menu that looks a bit like this. And then with one additional brain click, you'll call her caregiver to draw it and for attention, basically. Take home from this is I think that even very limited control signals, brain clicks and call caregiver are really valued functionalities, especially in a situation where conventional AAC falls short. And that really implanted BCIs can thereby, even despite their limited, address unmet communication needs for over multiple years. In our case, she used it independently for almost 7 years. Nocturnal BCIs may require dedicated or adaptive decoders, and ALS progression may eventually also decrease BCI efficacy again, at least in some users. We cannot really generalize this yet with the numbers we have so far. So the next steps are, and Jonas already hinted at that, within 3 different projects, Corticom, Intense, and Intercom. The last one is the collaboration with Jonas and the VIS team, use advanced implant technology to accomplish faster BCI-based communication at home, investigate the functionality and the longevity of the efficacy in settings of daily living with more participants, because we really need to understand what's going on, for whom it will continue to work and for whom not. And we'll be very interested in collaborating with clinicians, patients, the industry, and also regulators to develop standards of care and clinical procedures for the real-world application of implanted BCIs. And with that, I hope I'm in time. Many thanks to our team, wonderful multidisciplinary team, and many thanks to our participants, funders, and collaborators. And thank you for your attention.
Thanks so much, Mariska, for really a great presentation. And 2 things that you prompted me to say. One is, which is true not only for your presentation, but also the ones both before and after you, is it's a great example of how even the academic research that is really based on developing systems that will eventually find their way to clinical utility as really created by industry. These academic research endeavors can provide, quite often, as we're already hearing, some value to the participants who are joining us in these clinical trials, even if that's not the reason that they initially joined the trial. So really, thank you for emphasizing that home use. I couldn't agree more. I'll also take this opportunity to remind both our industry representatives and everybody else who's here today that we're going to have a Q&A just on the other side of the break. So as you have questions that you're thinking about, either for the individual presenters or for the entire panel, please keep them in mind. Feel free to add them to the chat at any point over the course of this afternoon, and we will hopefully be able to get back to as many of them as possible once we get to that discussion later today. With that, it's my pleasure to turn to Dr. Nathan Krohn. Dr. Krohn, as Nathan, is a professor of neurology and epileptologist at Johns Hopkins, and he's going to be telling us about his continued work, which is a perfect segue from Mariska on electrocorticographic BCIs. So, Nathan. But we can't hear you yet, Nathan. I see your slides, but I don't hear you.
Okay, I think that's now you got it.
Now we hear you. It's all yours.
Okay. Yeah, I was thanking you for the invitation. So I'll just jump right into it. We have a clinical trial that we've been doing at Johns Hopkins in collaboration with the University of Utrecht, with Mariska, and with Nick Ramsey. And we're really trying to see whether an ECOG BCI can deliver more capabilities and performance if it has more electrodes and better signal quality than was available with the PC plus S device that was used in the Utrecht neuroprosthesis. Corticom is a phase 1 early feasibility trial of a 128 channel ECOG device composed of 2 FDA cleared components that are combined in an investigational device being studied under an FDA approved IDE. The ECOG electrode sheets are made by PMT and have been used for many years in epilepsy surgery patients. These are connected to a computer through a BlackRock patient pedestal, which is shown here. This is the pedestal, and then through the Neuroplex E, which is a head stage and amplifier that then connects to a mini HDMI that then goes to the computer. You can see it here in this picture. These are the electrode sheets. This is the actual device itself with the pedestal connected to the pedestal. This is just different views of that. And this we've already the initial study period is for 6 months, but it can be extended up to 4 years in the absence of any safety concerns. We've implanted our first participant of 3 planned at Johns Hopkins and 2 planned at Utrecht. There have been no safety concerns to date in our first participant. And our first participant, his name, he doesn't mind us sharing that. His name is Tim. He's a 61-year-old man with slowly progressive form of primarily bulbar and upper extremity ALS. That he has dysarthria with very reduced intelligibility and then upper extremity weakness. And you can see this is it's funded by an NINDS UH3. One of the things we've been studying with Tim is switch scanning. Zoe already demonstrated how PALS can use switch scanning with a letterboard, and this was also used by Felix, which was just presented by Jonas. This is arguably the most basic form of communication one can use with BCI, and also the participant that Mariska talked about was using switch scanning with a brain click. We wanted to see how well this would work when we have many more electrodes over the upper limb area. So here we created a spelling application in which a brain click is used to select appropriate letters and words to spell sentences. And to speed up the process, we used a predictive language model to provide better suggestions in the top row. You'll see in the video that I'm about to show that this is what the application looked like. So Tim made attempted grasps. He actually only could make a little movement with his fingers and to generate clicks. We trained the algorithm with data from 44 minutes of Tim making these grasps, and didn't actually get to test it until about 21 days. And then we didn't change the algorithm at all for 90 days. So the median sensitivity for this was 97%. So 97% of his attempts, we could see his actual attempts to make that grasp. So that was the advantage of having some residual function that we could see and have ground truth. The detection latency was less than half a second. The false positive rate was very low, about 7 per hour, and then the median spelling rate was about 10 characters per minute. And most importantly, it was stable over 90 days without any retraining of the decoder. And this is something that we thought was something we were looking forward to with electrocorticography as a modality for BCI. The next thing I'll tell you about is using speech control of devices. In particular, the example I'm giving here is control of a communication board. So I think everyone is familiar with a communication board. There's many different varieties of these that can be used. And our goal here was to allow Tim to navigate and to select and then deselect items in a communication board, and then to use that through that and that form of communication to control devices as well. So I'll show you an example of that. The idea behind this, the rationale for this, is to try to achieve as high accuracy and reliability without relying on a language model. When really the commands are right, left, up, down, or enter or back, there really is no language model that can help with that. It's either right or wrong. The command is either right or wrong. So we also thought it important to be able to have self-paced, to be able to issue these commands and decode them in a self-paced manner without any external cues, and to be able to limit the need for retraining or recalibration. And I'll show now how that worked. A couple demonstrations here. In the first demonstration, and Tim is actually saying enter, enter, enter 3 times in order to enter into the communication board. And now he's navigating towards to turn off the light. And he is able to speak, but his speech is not intelligible enough for Siri or Alexa. Here we sped up the video, and now he's navigating to YouTube to select a video to watch. And here we were decoding his overt speech. But in another video I'll show next, we were able to do this with silent speech. So just mouthing the words. So here he's navigating through YouTube to find a video that he wants. Unfortunately, we didn't have the commercial-free version. So the next video I'll try to show here is him using the communication board with silent speech. So the emphasis here on accuracy without having to use a language model to issue and understand commands to control a computer and devices, such as a light. The median accuracy here was about 91%. There was no decline at all over a 3-month study period. There was no model retraining or recalibration during that time, and no exogenous, no timing cues, except for at least what's shown here is for the silent speech did require a timing cue, but for the overt speech, it was all self-paced, and we're working on improving on that. Our future directions are to increase the number of electrodes. We are working with the Wyss Center as well to try to develop a wireless device, and we also are working on speech BCI with brain detect, brain to speech, upper limb BCI, cursor control, robotic control.
Excellent. Thank you, Nathan, for a great presentation, for the update on the great work that's happening there at Hopkins. As you can see, there was some planning to all of this from Jonas and Mariska and Nathan, so it's all flowing very smoothly. We'll now continue on this well-planned approach to David Moses, who's going to be joining us from UCSF, to giving us some updates on the work he's doing together with the Chang Lab there at UCSF. And David, now we hear you. So go ahead.
Okay, great. Thanks so much for the introduction and for all the great talks so far, and for having me. My name's David. I'm in Dr. Edward Chang's lab at UCSF, and we work on something similar to what Dr. Krohn just presented, using the same kind of interface. And I'll just talk a little bit about that. I think we can skip a little bit of the intro because everyone's done such a great job of explaining that so far. But just to reiterate, we believe that speech is really a rapid and efficient communication method and very expressive and personal. And so even though assistive technology can be transformative for patients with ALS and other conditions, we do believe that a speech BCI, such as a system that is depicted here, would be really even more transformative for patients. And so really briefly, just to summarize what's already been described, you can have a person who is unable to speak try to speak, and then a neural interface, here's some example neural interfaces shown here, can record the brain activity and translate it through a data processing system into audible or textual speech or other forms of speech. And how can we even start to think about this kind of problem? Well, I just wanted to give a brief overview that for over a century, people have been studying speech representations in the brain and how we can understand the way that speech is encoded in brain activity and how we can decode that brain activity into speech. And from all of this, this led us to start a clinical trial called the Bravo trial. And our goal is to see if everything we've learned, or what about the things that we've learned, can generalize to patients who are unable to speak, because that's really our whole goal, right? Is we want to make the technology into something useful beyond just understanding speech. We want to actually make something that will help patients. And so in this trial, our goal is to validate the efficacy of ECOG, electrocorticography. And so this is, as Dr. Krohn and Van Steensel described, sensors that sit on the brain surface. So they do not penetrate the brain, but they're implanted in the skull directly on the brain surface, and they record electrical activity. And we want to study these neural representations of speech in patients who are unable to speak, and also develop speech BCIs. And so our first participant, Pancho, is really an incredible person. We're so fortunate to have him. This is him, so blurred out to protect his identity, but this is his system that he uses to communicate. He had a stroke. He's very sharp though, but just is unable to move significantly and unable to speak. And we implanted this 128 channel array over this part of his brain, which is the speech motor cortex. This is the part of the brain that allows you to control your vocal tract and speak. Okay, and so here's an overview of our first system that we developed with Pancho. So in brief, Pancho sees a sentence and tries to respond to that sentence using words from a 50-word vocabulary. Brain activity from all 128 channels is acquired, processed, and basically decoded back into a response, the response that he's trying to say. And so here's a quick video of him using the system to respond. So here's the prompt that he sees. These dots indicate that we've detected an attempt to speak from his brain activity, and this is us decoding his attempted speech and presenting it on the screen. And we were really, really excited with this proof of concept because not only is it a really kind of inspiring thing to see work, but it also is one of the first times we've understood that someone who has been unable to speak for so many years, over a decade, still has representations of speech in his speech motor cortex, which is very promising for future technology. And so we actually have a newer participant, Anne, even though we still work with Pancho, who has a similar condition. But we actually...
David, I'm just going to jump in for 1 second. I don't know if there was audio in your prior movie, but if there is, it's not shared yet. So if there wasn't, then please go ahead and share it.
That sounds good. There wasn't audio in that one, but if you can't hear the audio in the later one, then please let me know.
Okay, sorry to interrupt you. Thanks.
No worries. Thank you. So with Anne, we have an upgraded channel, similar technology, similar approach. It's just an upgraded array with more channels. And so here's these dots are showing where the electrodes are on the surface of Anne's brain. And so what we developed with Anne is a new kind of BCI that we're calling a multimodal BCI. So similar to, I think, what was discussed in the introduction of Zoe, great presentation, by the way. I'm really interested in learning more about your virtual embodiment of patients because it's something that we believe in. And that's one of our goals with this, is to have a really expressive multimodal speech BCI, where Anne is attempting to speak and we are decoding her attempts to speak into text, audible speech in a personalized voice, and an avatar animation. So a facial avatar that's customizable that animates alongside the speech. And so to kind of quickly go through some of our results, we were able to get really encouraging decoding of unseen sentences with 1,000-word vocabulary. Here's some example sentences that Anne was attempting to say and what we decode. This was all occurring in real time. And just to keep moving, this is a brief overview of the kinds of speech that we are able to generate. So this might be a little unfamiliar to some, but these are basically showing 3 different sentences in the columns here and showing that the representations of the actual target speech are very similar to what's decoded. And these aren't references from Anne's speech because she's unable to speak. They're just reference waveforms that are computer generated. And then finally, in the third modality, we have the avatar control. So this is just really briefly showing that people who are watching and doing lip reading on only the avatar animation are able to do a binary classification task, so either right or wrong, 2 choices above chance, and also that we're able to decode some facial expressions, including articulatory movements like lip movement and mouth movements, and also emotional expressions. And so I'll show a little bit of this in a second, just showing the full system again. Here's a video. Please let me know if you can't hear this one, where Anne is attempting to say sentences, and we're decoding the text, the speech, and the avatar in real time.
Thank you. Wonderful. We need a few minutes. What do you think of my artificial voice?
Okay, and here's excuse me, and here's some expression decoding. So in this one, she is attempting to make emotional expressions, and we're decoding that and using it to animate the avatar. So that was a happy. Oh, sorry, the first one is happy. This next one is sad. It's a little subtle. And this final one is a surprised face. Okay, and for us, long-term, oh, excuse me, I'm coming over a cold, so my voice is a little messed up. So long-term usability is really important to us. And we see with Pancho that even over like 3.5 years after implant, he's still able to use the system, even if we freeze the decoding model and try to run the classifier then. Oh man, now I'm really losing my voice. And then with Anne, we are able to do something similar, but we haven't gone to the 3-year mark with her yet, where you're able to freeze the model and not retrain it, not recalibrate it, and still see good performance on a 25-word and 26-word classification task. I'm gonna kind of speed through this in the sake of time, but we show that our approaches can scale to large vocabularies, and that we believe as the number of electrodes increase, we can continue to improve performance. I want to get close to the end with some feedback from Anne, and I'm just going to display some of this on the screen, but I really want to focus on the avatar one because it was really interesting to hear what the avatar could mean to her. She wants to become a counselor, to use the system to talk with clients, and she wants her clients to be other patients with paralysis. And we really do believe that in an increasingly digitized world, the virtual experiences offer something that perhaps patients with ALS and other disabilities can't experience in the physical world. And so we think that it can be a really freeing and embodying restoration modality. Here are some avenues for improvement as we build towards a clinical solution, because I think from all the great talks today, we can see that speech BCIs are definitely possible. So we want to validate on more participants, continue developing our applications, improve the hardware, and improve the modeling. Okay, thanks so much. And I want to thank all the funders and collaborators and our patients, participants. Thank you.
Wonderful. Thanks very much, David, for that amazing presentation and just describing just some of what the incredible group there that you and your colleagues at UCSF are all working on. And for our last academic presenter today, all the way from about 20 feet in that direction, is Dan Rubin, neurointensivist at Mass General, one of the PIs of the ongoing BrainGate research, who will tell you about some of the ongoing research from that group. Dan, it's all yours. But ask you to unmute as well.
Have to unmute. Thank you. Excellent. Thanks, Leigh. Thanks, everyone. As Leigh said, my name is Dan Rubin. I'm a neurologist at Mass General, an investigator on the BrainGate clinical trial. And here are our disclosures. So at BrainGate, we think about what we're doing and the work that we're doing with a couple of simple goals in mind. And the one I'll share with you today is our goal to be able to tell all pals and their families that you will never lose the ability to communicate. We've been doing this for a while, and the way that we approach this goal has changed over time. When we first started, the way we wanted to ensure that people would never lose the ability to communicate was by giving them control of a computer cursor. The rationale being, if you control a computer cursor, you control it from your computer, and you can use the computer to communicate. So early on, we spent a lot of effort making sure that we could smoothly, accurately, and intuitively control a cursor on a computer. So our participants would think about moving their hand reach the arm in a particular direction, control that intended movement in real time, and give them control of the cursor on the screen. And doing that, our participants, here are two of our ALS, are able to control off-the-shelf consumer electronics. On the left is writing an email, on the right searching YouTube, and they're both using the BrainGate for these electronics. These are unmodified Google Nexus tablets. With this sort of approach of smooth two-dimensional cursor control of virtual keyboards, if you rearrange the keyboard a little bit and put letters that are commonly used towards the middle, you can communicate at about 40 characters per minute.
Dan, I'm just going to jump in for just a second. It turns out that the sound from the movies there is a little louder than you. So you may have to speak quite a bit louder to overcome that.
Oh, sure. Is that any better?
Yes.
Excellent. As I was saying, when optimized, our participants can communicate about 40 characters a minute with an optimized keyboard. And importantly, this system is agnostic to what sort of computer device you're controlling. So here, we're using off-the-shelf Google Nexus tablets. Another one of our participants here is using the BrainGate system actually to control two different systems. He's got his Windows PC up and he's surfing the web and searching YouTube there. And at the same time, he's got his iPad up and he's composing music in GarageBand. And he actually used the BrainGate system to switch between which of the devices he's controlling using a couple of different gestures that we can detect in real time. And so this is, we think, a very powerful system, but with our goal primarily being of communication, we often think, all right, well, how can we communicate faster? What's a faster way to communicate than typing on a virtual keyboard? And one way that people communicate faster is with handwriting. And so a couple of years ago, Frank Willett, who's one of our research scientists at the Stanford BrainGate team and has really led a lot of the innovative communication work, came to the realization that we'd gotten very good at decoding two-dimensional cursor control, that is, decoding the intended movement of the hand, wrist, and arm. And in fact, we got so good that if we asked our participants to imagine holding a pen or pencil and just writing out the letters of the alphabet, we got so good at decoding the intended movement of the hand, wrist, and arm that we could predict the position of the tip of that imaginary pencil. And if we traced out the trajectory of that imaginary pen or pencil tip, we could decode the letters of the English alphabet. And if you use this system as your decoding base, you can actually begin to give people the ability to communicate at much faster rates. So here's one of our BrainGate participants. He's been asked to copy the sentence that's printed on the screen at the top by imagining that he's writing it with a pencil on an imaginary piece of paper. And the letters that he's attempting to write are being transcribed in real time by the BrainGate system. And so you can see here he's copying famous John F. Kennedy quote. Of course, he doesn't just need to copy text. He can also just answer questions or write whatever he wants. Really, the system doesn't attend to that. So here he's answering this question. And with this system, decoding handwriting, he's able to use the system to communicate at about 90 characters per minute. And as a basis of comparison, this is roughly, that's not roughly, but it's approaching the speed that someone without paralysis might be able to communicate using something like a smartphone keyboard. I'll let him keep writing for a little bit. Get a sense of the cadence of this system. But of course, there's a way to communicate even faster than handwriting. And of course, it's what I've been doing for the past 4 minutes or so, and what many of our speakers have been doing, and that's speaking. And so a couple of years ago, we said, well, how can we approach this question of decoding intended speech? And the way that we did this was to move our recording electrodes, that is the microelectrode arrays that we use to monitor brain activity, and place them over the part of the brain that produces the electrical activity associated with the intended movement of the muscles of speech, that is the muscles of the face and the mouth. And in doing this, we actually train the BrainGate system, we train the decoder to try and predict what phoneme an individual user is trying to produce at any given point in time. A phoneme is the smallest individual unit of speech. Phonemes make up syllables, which make up words, roughly. And so as our participants attempt to speak, the system in real time is trying to predict what phoneme they're producing. And at the same time, there's a large language model that's running in parallel that uses the previous words and phonemes that were predicted and says, well, what's the next most likely word to come out of this? Those two probabilities are combined, the phoneme prediction and the language model prediction, to tell you what word the person's trying to say. And I'm going to show you a video of this system being used. The participant I'll show you is one of our participants who has bulbar ALS. And you'll hear, if the volume's at a good level, that she has rather severe dysarthria, and her speech is largely unintelligible, but the system is able to predict what she's trying to say and print it on the screen. I'll show you that.
I don't want to call her a babysitter. That would be good. I did well in school. I don't see much pollution turning on.
And like the handwriting system, she doesn't just need to repeat what's printed on the screen, she can also use it to express herself.
I am a very good friend and sister.
And in fact, you'll be hearing from this participant in just a few minutes, actually. So with this system, she's able to communicate at around 60 words per minute. In the videos I showed you, she was vocalizing. She doesn't need to, though. She can speak silently, so attempt to meld the words without necessarily phonating, and the accuracy stays the same. The accuracy of the system depends a little bit on how large a vocabulary is used. With a smaller 50-word vocabulary, get a word error rate of around 10%, which is about 90% accuracy. If you expand it to 125,000 word vocabulary, which is more or less all spoken English, you get an accuracy that's approaching about 80%. That was with our first participant. In recent months, we've with work that's been led by our UC Davis BrainGate team, we've been able to improve upon this significantly with increased number of arrays, larger, more sophisticated language models, more powerful decoding systems. And in fact, with our most recent participant, I'll show you in a video in just a second, on the very first day that he used the system, after about an hour or so of training with it, we turned on the system and let him attempt to decode his speech in real time, and with a small 50-word vocabulary, had a word error rate of less than 1%. I'll show you a video of him using this system here.
My nurse is very heavy.
And by his second session, which is to say the second time he used the system, we expanded the vocabulary to the full 125,000 word. And when using it for personal use expression, so he just wanted to say what he wanted to say, had basically perfect accuracy.
I have been waiting for this for a long time.
Play one more sentence here. This went back to the beginning. Sorry about that. So where are we going from here? So we've got a few goals ongoing. One, of course, is to increase the speed and accuracy of the system. We've also been now beginning to start looking at decoding some of the non-semantic aspects of speech. So things like speech prosody, that is the pattern and speed with which someone's speaking, speech volume, things like how loud or soft someone's speaking, and also inflection, pitch, and other aspects of speech that allow us to imbue it with more nuance. So aside from just the words someone's trying to say, how they're trying to say it, so that we can really make this technology into a more complete communication tool. Where do we go for our PALs? Well, we think that implanted BCIs are really en route to restoring communication. And I'd encourage anyone who's watching any of the incredible speakers today who are interested in learning more about this technology to reach out. And if there's a trial, consider enrolling. I want to thank this incredible team. You can see our moderator sitting front and center, but really it's this whole team that made this work possible. And even more so than any of these people are incredible participants who've been just unimaginably generous with their time, energy, and effort in helping us develop these tools that they know we're working on to help other people with ALS. And thank you.
Thanks so much, Dan, for a great presentation and a wonderful segue to someone who I just saw. I know has been online since we started, and but who just became visible as well. It is my pleasure to introduce Pat Bennett. Pat, good afternoon or good morning. I think still the Pat, who's really amazing work with the BrainGate team you just saw a few moments ago, was diagnosed with ALS in 2012, just 6 months after retiring. Stanford was her place of diagnosis, and she continues to be a patient at the Stanford ALS clinic. Pat's currently 69 years old, and she feels fortunate that her ALS symptoms that began with speech challenges have progressed slowly in comparison to many other people who have ALS. Her arms and legs are now affected, and she lives in assisted living, but maintains a high level of independence. She remains active and social and can often be seen in her neighborhood on her street, capable mobility scooter. I am going, Pat very kindly prepared some comments that to share with everybody. And I, in just a moment, am going to play those comments. And I'm going to look to Jen, to Jen DiMartino, to ensure that all goes well as this plays, and we will. You should be hearing that just about now.
I'm humbled to be sharing my thoughts with you today. I had no idea my ALS journey would result in me being able to make a contribution to the advancement of knowledge about brain processes, and specifically to help with the creation of tools to help people who cannot speak. My first symptoms of my ALS were impacts on my speech. I was known as a talker, much to the dismay of my grade school teachers and my parents. I still remember my third grade teacher asking my mother the trick to getting me to not talk in class. My mother's response was along the lines of, I was hoping you could tell us. But my ability to speak, and enjoying speaking, served me well. It defined me and helped me enjoy career success in human resources once I redirected it from the boy sitting next to me in class. ALS brings a terrible toll on the patient, their family, and everyone in their life. I'm no exception, but I can truly say I have benefited from my participation in BrainGate. I didn't start in BrainGate with an idea of doing anything as impactful as I now see it has been. I heard about BrainGate and the extension into speech decoding in one of my regular ALS clinic visits at Stanford Medical Center. The speech expert on the ALS clinic team had an office on the same floor as Dr. Henderson and was aware of the move into speech decoding. She thought I might be a good candidate. Serendipity. Even before my initial meeting with Dr. Henderson, I was committed to participating. How many people are given a chance to make a meaningful contribution to technology that would benefit a condition that not only affects you personally, but so many? I didn't have any concerns about the surgery or living with pedestals visible in my head. My lack of concern was warranted. I had an easy recovery. I would encourage any individuals who have an opportunity to participate in research to actively discuss any worries. If those can be abetted, you won't regret the decision. Think about the impact. Those who cannot talk will be able to stay connected to the bigger world, perhaps continue to work, maintain friends and family relationships, etc. Imagine the difference every day. Activities like shopping, attending appointments, ordering food, going into a bank, talking on a phone, expressing love or appreciation, heck, even arguing when nonverbals can use their speaking thoughts to communicate in real time. Being nonverbal can be lonely and frustrating. It's hard for people to know or hear the real you when you can't use your voice. This is the first step in giving all those who can't talk easier access to what's key to our being human, the ability to remain integrated in society and communicate with others. And for me, the first time the BCI resulted in actual speech is an incredible memory, one I will never forget. It worked. Words cannot convey the feeling. I was being heard after many years of silence. The incredible researchers proved real-life speech for the nonverbal would become a reality. I truly believe it will happen in the not-so-distant future. A solution is literally on the horizon. Overly optimistic, maybe. But given the talent and commitment of the BrainGate team, I believe I'm warranted in my optimism. I am trusting the team to prove me right. I would encourage others to participate in studies such as this. I have a purpose, I'm being useful, I'm busy, definitely not bored, and have made new friends from the research team. I was lucky to be given slow-progressing ALS. The added time I didn't expect allows my participation to repay that luck. I envision I will be able to continue to participate in the study for a few more years. In fact, I had to recently officially recommit to continue to participate beyond my one-year initial commitment. The FDA required this recommitment, and I was given two choices, an additional 1 year or an additional 5 years. I chose 5 years.
Thank you, Pat, so much. Not only, it's great to see you, not only for those amazing comments, but for all you've done to teach all of us in the ALS research community just what is possible using these implantable brain-computer interfaces. And we look forward to your continued amazing contributions to this research. So it is great to see you. It is, and we look forward to having all kinds of questions and answers just on the other side of our break. I'm looking at my itinerary, and it just became 2:35. We are exactly on time. Jen, you are recording this, right? I just want to make sure we've captured this being perfectly on time. With that, I'd like to welcome everybody to take a 10-minute break. We will return at 2:45 Eastern, which I think is 11:45 Pacific, and look forward to seeing everybody then. Thanks so much. See you all back in about 10 minutes.
See everybody soon.
All right, this is about our 2-minute warning. So I'll just ask our industry representatives to be ready to unmute and participate.
Yes, sir. Staying in line with the almost intimidating punctuality.
We aim to please.
Unheard of in academic circles.
Not anymore.
Not anymore, as of this day, yeah.
And I see Florian, I see Kurt. Michael, if you're there, if you're back yet, if you could just turn your video on just so that I know you're there, that would be great. And Vikash, and I see Vikash, great. All right. All right, we've made it to 2:45 or 11:45 or somewhere in between, depending on where you're tuning in from. Let me check with the with our bosses, Jen and Shel. Are we okay to begin?
We are. Very well done.
All right. So welcome. Yeah, good. Thanks, Jen. Welcome back, everybody. We will now go into a few questions and responses that will be posed by our industry representatives. Now, if you thought it was challenging to ask our academics to speak in 9-minute intervals, industry is constantly saying we have to move faster, we have to get things done. So we've turned the tables and we've said, all right, you each have 4 minutes to present and to provide some overview. So really the goal here is probably over the first minute or so, each of our 4 representatives, who I'll introduce in just a moment, will be just tell you a little bit about the hard work that they're all doing at their respective companies. They then hopefully will be peppering our academic team with some questions that we will keep track of in serial. And then once they've wrapped, we will begin to have a moderated responses by between our academics and folks from industry. And then we will be able to open this up to a much bigger Q&A, and really looking forward to everybody's questions. Please feel free to put them in the chat earlier rather than later, or of course we'll have this become open when we get to that section. So much like we did before, let me introduce our 4 industry representatives. The first person we're going to hear from is Florian Salzbacher. Florian's the co-founder and chairman of BlackRock Neurotech. He's also a professor at the University of Utah, and BlackRock's the maker of the Utah array that he'll be telling you about and used in multiple studies today. Following that, we're going to hear from Kurt Hagstrom. Kurt is the Chief Commercialization Officer at Synchron, developing the Stentrode, which you will hear more about from Kurt. He'll be followed by Vikash Gilja, who's the Chief Scientific Officer at Paradromics, also developing an intracortical BCI. And then we'll wrap this brief session section with Michael Mager, who is co-founder and CEO of Precision Neuro, which is developing an intracranial BCI as well. So with that, looking forward to hearing everybody's questions and thoughts. And Florian, I'm going to hand the mic over to you.
Thank you so much. It's a great pleasure and honor to be here. Thank you so much for the introduction. Up front, I wanted to say thank you to all of you, starting off with Dr. Lalji and your daughter for setting the stage in the introduction. I think it is important to bring everything back to why we're doing all of this. It was very, very encouraging to see all those people coming together, including the large group that is here today, with ideas and collaborating across nationalities and boundaries. Because in the end, it's really one of those problems where I don't think it is one team or one specific solution that will fix it all. it really takes a village to get this done. With that, I want to jump straight into some of the questions. I think we're all united in what we're trying to accomplish here. I think it is wonderful to see the diversity of different approaches and aspects and challenges. And I do believe that there is a combination of advances that go all the way from, large language models, AI, advances in signal processing, advances in just clever approaches like the Stanford approach with the handwriting, for example, but adding other components that somebody like me, who's coming out of the materials and sort of hardware engineering side, may not have come up with the importance of things like an avatar or something that represents your voice and your facial expressions and all of this. I would like to sort of send one question out to the entire group of academic community that I'm partially part of as an engineer, but those of you who are really working a lot more with the participants directly. Do you think you're able to identify which areas constitute the largest challenges right now, or where the largest gain could be had in terms of what matters to the people who need the technology? Because, people are talking about electrodes, but, there's quite a few cases now where people have shown that these can last up to a decade. And yes, there's work to be done. How important is that? There's the algorithm, the signal decoding. There's so many different aspects. Where do you see the biggest potential and the biggest challenges? Where, if, for example, BlackRock were to say, we're pushing this forward, where should we invest our development dollars? What should we pick up and translate?
Great. Thanks very much, Florian. We will move over next, who's right next to you, Florian, on my screen. This is Kurt.
I was just hoping that I would get the answer also within my 4-minute increment, but
no. We will save you save your questions. We'll also save the answers. And we'll come back and have the answers back in just a little bit. So we will slide right over to Kurt Hagstrom from our colleagues over at Synchron.
Very briefly, thank you to the entire community working with us. I'd forgotten that in the thank you at this onset. Didn't want this to be lost. Sorry, I'll be quiet now.
Thanks, Florian. Over to Kurt.
Yeah, hi everyone, and it's really been an amazing discussion, and humbled by I think all the stories, and to be honest with you, all the amazing research that I'm seeing here today. To look at some of the things that you've already tackled, Mariska, during your talk, I'm already learning. For what we're and applying what some that you had on your talk and what we're doing here at Synchron. But just as a note, so Synchron. I work for Synchron, the chief commercial officer here at Synchron. We are developing a brain-computer interface that is delivered through an endovascular approach, through a minimally invasive approach, where we are taking the blood vessels as an access point into the brain to be able to collect signals over the motor cortex. Our system's, again, a completely wireless system that, again, allows the individual to control a digital environment. I think some of the things that we have kept in focus, and it's kind of our guiding light, is things that that have been touched upon at some of the talks already. That the system needs to be accessible, when they need it, such as at night, in the morning, and throughout the day. Has to have little help with the activation of the system. Being able to use it on their own when they want to use it is key. Driving minimal calibration is also making sure that they have the system that's usable for a long period of time. And then again, just going back to that fully implantable, not having to use it so they can use it outside, at home, which is, I think, where we'll see that obviously the high utility of the system. So look forward to the questions. I have a pretty good question, I think, and that, again, we're here at Synchron, we're in that translation from the academic and research element to this, to the clinical environment. We just finished enrollment of our early feasibility trial here in the United States, and continuously working with our patients. And then we're moving on this clinical journey, and then at one point, hopefully not too far in the future, a commercialization phase of our journey. But look forward to all the questions and the discussion later on.
All right, great. Thanks very much, Kurt. We're going to slide over now to Vikash Gilja. Vikash, who's the CSO there at Paradigmics. And Vikash, look forward to your thoughts and questions.
Great. Thank you, Leigh, and thank you everyone for organizing this amazing event. It's been incredibly inspirational to see all of these different perspectives and advances across the space. Paradromics is actually really building on top of much of what we've seen already. I mean, we're building on top of the shoulders of many giants to build a medical device that follows many of the strategies of existing neuromodulation devices like DBS systems, while enabling the neural interfaces that will allow the types of applications that you've seen, the broad range of applications. And so we are really focused on bringing that medical device to reality. And that is what we're thinking about on a day-to-day basis, along with the overall needs of our future users of this technology. And so a lot of my questions center around user needs. And if I think about the field, kind of wearing my academic hat, I come from an engineering focus. We often align ourselves to metrics to make progress, right? We have performance numbers, and you've heard many performance metrics already in the earlier talks. And so a question that I have is, as the field is advancing, how do we better align these metrics to user needs to really know that we're making progress in a way that's meaningful for our future users? I have a second question that's more kind of industry thinking and industry facing. This is again a question for my academic colleagues. As industry pushes towards medical devices for a diverse set of future users, so beyond our early participants in these studies, what are the salient challenges that you see to meeting that broader set of prospective users? And then final question sort of is at the intersection of academic and industry, which is how do you, as academics, envision academic industry ecosystems evolving, again, to best meet the needs of our future users? So again, looking forward to more conversation on this. Thanks.
Great. Thanks so much, Vikash. And last of our four, certainly not least, is Michael Mager, who's going to be presenting and asking some questions from Precision. And Michael, hopefully we didn't make it too challenging by having all the other questions that were asked first, but I'm sure you have many more. So over to Michael.
I'll try to be original. Thanks so much, Leigh, for inviting us and for this extraordinary group of stakeholders in this emerging field. It's just incredibly impressive and inspiring to hear these stories. So I'm, as Leigh mentioned, I'm the CEO and one of the co-founders of Precision Neuroscience, which is a company developing an implantable BCI based on a cortical surface array, sort of based on the basic concept that a few of the groups here discussed. We have about 47 people. We're based in New York, which is where I am now. The company is a little bit younger than some of the other ones that have presented. We're a little more than 2.5 years old. I think in that time we've done quite a lot. It's been a busy period, and our focus is really just on delivering clinical impact. It's very focused on taking technology that we know works and delivering it to patients that are hungry for new approaches. A few of the sort of advances that we've made since starting, I think we designed sort of a wholly new cortical surface array that is much higher resolution than anything that to date has been clinically available, and is extremely thin and conformal to the brain, so like 1/5 of the width of a human hair. We also acquired a facility in which to manufacture it, which is a very sophisticated microfabrication facility to make arrays that we found no supply chain in the United States was capable of delivering on. We've patented a approach to delivering a cortical surface array that obviates the need for a craniotomy. So it's a minimally invasive approach to insert an electrode array into the brain via sort of a very thin slit in the skull and in the dura. And we're advancing towards clinical impact. We've done 5 human implants so far. all in the intraoperative setting at the University of West Virginia. And we're moving to Penn and Mount Sinai and going from one site to three later this month. So that's a little bit about sort of us. You know, we like the other industry players are developing sort of a fully implanted chronic system that hopefully will be available for patients to take home with them, you know, where you don't need technicians and a laboratory to operate the system in a safe and very stable way. My question, and I can't quite tell if I'm supposed to ask a question now, but everyone else did. So I'm going to ask one question now. For sort of the academic experts that have been on the call, I'm curious what people think of as if you had to separate the challenge into sort of hardware and software, i.e. the physical interface itself, and then the decoding of the neural signals that we're recording from the brain. And you had infinite budget to do one or the other, but not both. You know, where you would apply the money and where sort of the more significant bottleneck is in terms of achieving, you know, meaningful human impact. Anyway, thanks for having me.
Thanks so much. Thanks, Michael. And thanks to our industry panelists for jumping in with their questions, which is exactly how we wanted to start. And, you know, I think one thing just to kick us off before our question, I think everybody realizes that while the academic groups who are presenting their research today have the opportunity with both federal and philanthropic funding to show what is possible with an implantable brain-computer interface, the final reduction to practice, the actual decision of what is the product, and getting that product across the finish line of pivotal clinical trials and then hopefully market approval and the subsequent reimbursement is ultimately not the job or within the skill set, largely speaking, of academics, but it's very much one that has to be achieved by industry. So I'm super appreciative of our colleagues from industry being here today and for all the work that you are doing to help to bring these ideas really across what we hope will be multiple finish lines for people with ALS. So with that, why don't we, I'll start off by combining a couple of questions that we heard from some of our panelists, and I'll try to get responses from each of our academics. This is where hopefully the wheels won't come off, but I'm going to either start calling on people or I'll let people just jump in, whether it's, well, you all know who you are. I'm looking at you on the screen, and if I need to prompt responses, I can do so. But both from Florian and from Michael, you know, we just heard really a question that we don't get asked all that often, which is if you had infinite resources or at least a lot more resources academics than you may typically be thinking about, that is the kind of resources that become available through investor capital. What would you do first? What is the biggest problem that you would fix? What is the biggest challenge that you as an academic from your perspectives on this research? What would you address first? And I'd like to hear everybody's response to that. So let me see if somebody wants to jump in or if I should start calling on my colleagues.
Leigh, can I respond?
Yeah, please go ahead, David.
Please go ahead. Great. Yeah, I mean, it's funny for me as someone who's worked on mostly software all for my whole PhD and my postdoc and now even moving forwards. But I do think if you had infinite resources, it should be invested in hardware upfront for many reasons. I mean, one, if you look at all the companies that are here today, thanks for your brief introductions, everyone. Everyone is kind of a little bit different hardware. It's kind of the defining disambiguation. And I think that in terms of making something that's very safe and effective and reliable and can get past regulatory compliance, like these are really, really not trivial. I think software is, of course, extremely important, but I think with a lot of people interested in machine learning and artificial intelligence in general and all of the great things that we can do in research in the academic sphere, these problems I feel a little bit more confident on people being able to develop solutions to. I think the hardware is really what will facilitate a lot of growth in the field. We already have great hardware, but I'm really excited to see where we can go from here to make what will really be like actual clinical solutions. And because if you don't have good enough hardware, then you won't be able to get the type of data and the type of system that you need to actually help patients. So at least that's my 2 cents.
Great. Thanks, David. Brian, I see you unmuted. Go ahead.
I agree with that completely. I think that in terms of what we talked, somebody spoke before about, how this can't be done in a silo, and the solution isn't going to come from one lab group figuring it all out and then disseminating that knowledge. I think that kind of democracy in the effort is possible on the software side, and like creating algorithms and doing all of that kind of research. It's probably not possible for that, the hardware side. There's such an incredible amount of oversight that is necessary for the clinical trials that we do. If that went away with a magical device that was fully implanted and lasted forever, and now you just have a much lower barrier to entry, and we have people in the community with these implants that we're able to do experiments, and people working on new decoding algorithms. I mean, all of that really opens up the field a lot. So I would agree that the hardware would, if there were a magic bullet, a secret technology that was available tomorrow that solved all of the hardware problems, that would be the biggest, have the biggest positive impact on the field in general.
Thanks, Brian. Mariska.
Yeah, I agree with putting money on hardware, but from a little bit of a different perspective. I think there is some very nice hardware, close to being finalized and ready to be implanted in patients. And I think with an endless amount of money, I would just make sure that we have, 100 devices available for us to do the, software development and the academic research on answering questions, who to eventually implant in a clinical kind of treatment program to address communication needs. To really assess that without, some company going bankrupt, basically. So to ensure that there's large numbers of currently available, very nice technology available, and, do large studies, because I think that's what is currently lacking.
Thanks, Mariska. There are other thoughts from our academic colleagues on the hardware versus software? It's 2-1 so far. Let's see if we, not sure this is actually a vote, but Nathan, Daniel,
I vote for hardware as well. I think we could use better hardware, and I think that includes the implant methodology, which there needs to be some innovation there if possible. That kind of goes along with the hardware, but yeah.
There we go.
Thanks. All right. Other thoughts? We have some other questions. All right. Well,
I agree.
Go ahead, Josh.
I agree. And just maybe chiming in on Mariska's point. So the long-term support of hardware is also very important, right? We've seen companies go away where the model didn't turn out to be profitable, but people stay with their implants, with their technology, and it's kind of a secondary issue, but something very important for users that use the technology, I think.
Yeah, thanks. Maybe we'll get a chance to come back to that important question. We may turn the tables a little bit on our industry colleagues and look to all of us, including in academia. How do we ensure when devices are deployed, either as part of an academic trial or as part of a corporate sponsored trial that is on the way to marketing approval or to a PMA, how exactly do we ensure that those devices will remain viable and supported even beyond, for example, the 5th year of a 5-year grant? This is a real challenge in academia, but let's come back to that question in just a little bit. One of the other questions that was asked is, not only we just had a little bit of discussion of hardware and software, but another question that was posed is, where is the biggest gain in terms of what matters to PALs and to other people who would use this technology. We're going to hear from more of our audience, including pals who are tuned in today in just a little bit. But let's just start with seeing what the academics' perspective is on this at the moment. We'll return to industry, and then we'll hear from the people whose answer matters most, which is our pals and our caregivers, people with ALS. So what is it? What is the outcome that we're hoping for? Mariska, I see you're unmuted.
Yes. Well, to be honest, I don't think the academics should be answering this question. I think we have to ask the people who need the devices. But from what I've seen with our participants, the things that they have expressed, at least, and I can only convey what they've told me, is that something that is extremely easy to use, that is always stable, that doesn't require a lot of calibration, and that just always works all the time in all circumstances. I think that's where we can really make a difference. But again, I think that the real needs should be coming from the users themselves, the potential users.
There's no doubt about that. Agreed. I think if we were all giving the thumbs up at once, you would have heard that across the board. I do see Shel. You want to jump in?
Yeah, great question, Leigh. And I think that, I can certainly speak for a lot of the pals that, we've discussed this issue over the last several years of being on this journey ourselves. Pals want to have technologies available to them early on so that they don't have span of years of no communication, limited to no mobility, and particularly when the eye gaze devices start to not function anymore. So like Mariska said, certainly consistency is very important. Certainly it's very important to not have as much need for constant tech support or tweaking. And of course, we're talking future, right? We're talking some present, some future. But as the people on this call, the experts in the field, academics, industry, are really focusing on what is it that pals and CALs are looking for, it is truly reliability, consistency, high-tech approaches, as well as access. Access is the biggest thing. How can we offer this to as many pals as possible yesterday, right? So how do we do this? How do we get to that finish line sooner than later so that we are the people that we're talking about who are struggling every single moment of every single day? How do we not keep them struggling and waiting? So that would be, a perspective from pals and CALs.
Thank you, Shel. Let's see if there's some responses from either academia or industry to those really important points. How do we get there faster? I see Florian, then Kurt. Yep, go ahead.
Yeah. Oh, sorry. Go ahead, Florian.
No, Kurt, go first. I'll go second.
Yeah, I think these are all really important, I think, characteristics and needs of this system. For us in our journey right now, and again, we're taking that journey, with a regulating partner. So, you go regulating and also CMS. So when you look at offering these technologies in a broader group, ensuring that, as you design studies, that they're capturing, critical tasks that are needed to show, say, quality of life improvements. So I think that's one piece. And one of the questions I was going to ask, and again, this is, I believe, also something that we need to either go to the carers and or the patients themselves as you look at now translating what are the clinical benefit or what are the activities they need to do to drive independence and autonomy, but then how does that affect their health? Because one of the questions that we have to solve as a BCI community is how does the BCI impact health? And therefore, once we solve that, you look at CMS, at least in the United States, CMS is the folks that can give that scalability across by reimbursing this technology, and also the FDA. But this is a medical device, so it has to have medical purpose. And so linking these activities in the medical purpose of the device is critical, I think, for a community, and also making sure that we hear that voice from the patients. But any thoughts on that would be of interest, as a lot of the folks here have dealt with the patients, and also they're managing their health along with their capabilities.
Thanks, Kurt. I just want to reflect on what Vikash, who's next to you on my screen as well, had just raised, which is how do we get from the metrics that as neuroengineers are common, and we know exactly what they mean, and they allow us to measure our progress. But that bit rate isn't something that necessarily somebody with ALS wants to even know about, let alone use as the method of tracking the performance of their system. What are those outcomes measures, just Kurt, as you were referring to, that will be most relevant for PALs, for caregivers of people with ALS, and for others in the community? I agree, this is a really key question. Would love to hear feedback from everybody in the panel and others. Florian, I don't know, I know that you were unmuted before, if you want to jump in there. But I'll ask you to unmute, Florian, before you do.
Sorry, you muted me there first, so thank you. So I'm trying to integrate that now into what I was going to say. I think what is really important, and where the families, the patients, and the caretakers can really help, is with the outcome measures and the communication, what constitutes medically treatable conditions, because we're starting to run up against certain limitations. Obviously, communication is very important, but there are a lot more things that can be done, and the reimbursements are fairly limited in order to address one of the comments about this being not only a charitable and meaningful contribution, but something that is commercially sustainable. We have to try and couple what from a common sense approach makes sense to everybody to have in terms of technologies with what from a clinical medical point of view may be deemed necessary or treatable. That is really, really important. And the more we can accelerate that, the more we create markets and opportunities that then warrant the investments. The other thing that I wanted to comment on is the reliability. Now, that is close to my heart, because in the end, this stuff has to work. Otherwise, it doesn't matter. It becomes a science experiment. And whereas from a technology point of view, that is fascinating and important, and it's a little like going to the moon and demonstrating what mankind can do when we put our mind behind it. But it really only matters when it becomes robust. I do not think that at this point in time, it is entirely clear that, again, it is one individual component. There's some that are more important than others, but what the presentations today have already shown is that there are many approaches to getting to long stability, good data, and good function, because, again, the user couldn't care less what the data rate is, what the metallurgy on the device is, whatnot. They want it to work. And I think as a community, we can merge this together. There are clever software approaches and data analysis approaches and other components that can compensate for maybe at the face of it sometimes deteriorating input data quality and whatever. And so, as I said, I think, again, it goes back to working together and jointly working on all the aspects that can help improve reliability, rather than just saying, the algorithms are crap and static, or the electrodes don't last long enough. And now that ties, it's the final comment, into the regulatory side. We really, really have to find ways to allow changes, at least on the software and data processing side, to happen much, much more quickly, so that we can benefit from the kind of turnover that we have with these devices and not get stuck in the traditional, this is a DBS system, this is a cardiac pacemaker, and it is life supporting, and therefore any kind of switch in one variable in the software, and you have to run through the entire validation process again. We have to find ways to have at least the external part that is not part of the implant become something where we can benefit from the much quicker turnaround in innovation and ideas that the entire community brings across, so that as a company, we can say, we love this algorithm, we love this idea, and in 6 months it's on the market, not in 6 years.
Thanks. A lot of really important insights there. Florian, Vikash, I see your hand raised.
Yeah, I was just going to build on Florian's comments in the sense of bringing together my question and then the question that came up about sustainability of an emerging industry. And from my perspective, building that overall cross-industry, cross-academic ecosystem, setting standards together can help secure some of those future applications for our users, right? If there is good agreement and good collaboration at this level, I think we de-risk some of the concerns that have been brought up. And I think, you know, this type of event where we're all together starting to talk about this is part of that process.
Great. Thanks, Vikash. I'm looking around. I'll just as a quick search. Oh, Daniel, I'll head over to you, and then Mariska. I see both. I saw Dan's unmuted, and then Mariska, who's got her hand raised. Just as a quick advertisement, though, really looking forward to beginning to see some questions in the chat from pals and caregivers, people with ALS. Please continue to add those questions to the chat, and we'll open up the mic as well a little bit more in just a bit. But all right, some combination of Dan, then Mariska, then Brian. Yeah, go ahead.
Thanks. I just wanted to echo what Florian was saying and what a number of speakers said. And in thinking about how to meet the needs of PALS and find out what they are. And there's a number of suggestions, including some that are suggested in the chat, like patient advisory boards, which are incredible. And you know, we learn so much from each of our participants and each of the stories that they share with us. And you know, the video demonstrations are so powerful, and you see people using this. And I think finding out how to make this technology work for PALS, part of that is just getting it in the hands of more people, and working hard to expand the scope and breadth of these clinical trials and moving them on, you know, to the point where you'll have a community of people using maybe with different hardware or different software, but as they begin to work together, they'll build their own community. The community of PALS using BCI will tell us what they want. But I think it takes getting more and more experience. People start talking to each other and using this and finding out the ways that other people are using their technology. And I think that's going to really lead to an inflection point in the development.
Great. Thanks, Dan. That's the second or third time that we've, I think, heard a really important underscoring of the enrollment in these clinical trials, even these ongoing academic clinical trials. The amazing demonstrations that we saw throughout the day so far are all the results of truly extraordinary people who are enrolling in these trials, giving an extraordinary amount of time and providing feedback on how well these systems work and how we need to continue to make them even better. So great points. Mariska?
Yeah, there's some things I would also like to stress that, you know, we already have, I think we saw that last week at SFN, worldwide there have been like 60 people implanted with a BCI, mostly aimed at communication. The data of those 60 people combined can inform us really a lot on what works, what doesn't work, you know, what stages of ALS may be kind of prohibitive for accurate functioning, what characteristics of the ALS may be problematic and what, you know, are not so much of a problem. So I think that, you know, increasing data sharing into large databases that then will be used to, you know, to answer these big, larger questions without, you know, having to run new, very large trials to answer them. I think that also could be kind of a low-hanging fruit. And the other thing is that any other implant studies, I think, should be focusing really on 24/7 recordings, because BCI should not only work during the day, but they should work in all circumstances, indoors, outdoors, during the day and during the night. My 2 cents.
Yeah. A lot more than 2 cents. As you know, that's unbelievably important points, both for everybody in the academic community and as we think about the future industry trials as well. Thanks, Mariska. Brian?
That just, it leads into what I was going to say. Somebody, I think it might have been Mariska, during the presentation said that really the metric that we want to be tracking is use. Like, if people are actually using it, that's the metric that matters, not bit rate, right? And that really encompasses everything. It's how well does it work? How reliable is it? Because even if you have a system that works extremely well 1 out of every 3 times that you try it, that might not be good enough and they won't even attempt. And so then it's still, that's a failure, right? So the usability, and hopefully as we have more systems that are take home. We use a take home system. I know BrainGate does. So as we get people available to use all the time, every day, all day, hopefully we could start to kind of get a better idea of what truly drives the that crossover into true clinical relevance when people are actually using it. What features of the control are actually most important for driving that?
Yeah, thanks, Brian. Undoubtedly, we have to, as a community, figure that out, which will help everybody, both academics and industry, to create the devices that have the outcomes that are exactly what our future users hope that these devices will provide. I see David and then Jonas.
Thanks, and apologies if this was already said, but 2 points. One is I do think that in addition to what everyone's already said about improving, of course, we want to improve autonomy, expressivity, connectivity of patients first and foremost with the technology. I think also improving caregivers' experience and the amount of time that they have to invest to help facilitate communication and, manage any kinds of frustrations over the interface. Because I know that, I've seen some of our patients try to use, just through my work, through my experience, patients trying to use eye trackers when it stops working. It's it really is just debilitating. I can't even imagine what it's like for those patients, and just being able to facilitate that and kind of lower the burden on everyone, not just the patients as well, and restoring reliable communication, I think will be really helpful. And the other one is for our participants in the trial, they're both really incredible, and they have expressed how they want to. One of the things they miss most is being productive. And so Pancho, for example, when he got his injury, is very young at the age of 21, and he decided to learn English. He only spoke Spanish. He learned English after being basically fully paralyzed, and started to create web pages. He got into web design, very, very painstakingly, letter by letter. And Anne wants to be a counselor, as I mentioned earlier, to help clients who are similar disabilities. And both of them just expressed how they really want a system that, like a brain-computer interface that can help them to be productive and to contribute back to society, because that's very, very meaningful for them. And so I do think that's another thing that we have to keep in mind when designing this. Of course, the core goals of expression of the patient is very important, and we want this to be as good of a user experience as possible. But we should keep in mind that productivity can play a factor, a meaning in patients' lives as well.
Thanks, David. Really important, great points about thinking not only about the immediate outcomes measures, as you will, but what those outcomes measures will enable for the users of our systems, whether it be in employment or education, or autonomy more broadly, and restoring the ability for people to do what they want to be doing, given these technologies. Jonas, I think you had Aaron.
Mariska mentioned that we have experience with maybe 60 people have been implanted. If we think about it, that's a ridiculously low number. We're scraping the surface here, and I think what is a big challenge for us as academics here is to really gather more data with patients who have quite variable etiology and history and experiences, and to come to the point where we have predictable outcome measures, where we get to the point where we say, okay, maybe a BCI that offers speech decoding is something that would work for you very well, and you can use it for another 5 years. Whereas maybe for other people, all we could possibly hope for is a switch, but still offering some communication capability for a number of years. If we get to that point where we can have where we can let people make informed decisions what kind of technology they can go for, I think that is a big challenge for us. That we should strive for.
Thanks very much, Jonas. The I'm just going to look around for a moment to see if anybody else wants to jump in. Momentarily, we will transition to, yes, Mariska, go ahead.
Well, the other thing that, I think all the people here in this call and many of the people we work with see the big potential of BCIs. But I think, at least in Europe, and I'm not really sure how that is in other countries, but I'm sure it's quite similar, there is still this idea that people with late-stage ALS, why bother? Very, very boldly said in the society. So I think there's also a need for us, and perhaps also for the ALS community, they could help us with that, to bring the story more about, life with ALS can be worth living as long as you can communicate, and therefore it's essential that we develop this technology to its fullest extent. So also trying to create a little bit of a shift in societal perception, what it is to live like this. And what the value of communication is. So I think it's not only within this little crowd, it's also, we should think broader and more widely. And this probably also relates to policies regarding, tracheostomy, invasive ventilation, etc., because that will directly affect the ability to communicate. So I think there's also some work for us as a community to do there, to convince society that this is actually a good idea, because it will maybe help, reimbursement at some point.
Thanks, Mariska. It's such an important point. And I think many people on the call, particularly given the progress that we've seen over the past several years in developing the BCIs from everybody who's presented today and the industry groups that are working on these technologies as well, is that there is a real moral imperative to do exactly the work that's being done right now, and to get across the finish line safely, and then, having said safely, as quickly as we can. And that really takes the multidisciplinary, interdisciplinary research and development that's happening, that's represented, here on this call today, and I know on all of the teams, both academic and industry, that are represented here today. So, Mariska, well said. Nathan, see your hand raised.
Yeah, thanks. Yeah, thanks. I think it's really just I think reinforcing what's been said already, but we really need really good market research for potential users of BCIs, and I'm concerned that I know that there are industry partners that are doing this market research and should be doing this market research. Is really important in order to determine the commercial viability of this field, but at the same time, that market research can be very very valuable to the industry. The question is industry willing to share that with each other? Hopefully so, and if not, should we have more of an academic approach to that market research to share that information? Yeah.
I see two very rapid responses from Florian and Michael. That's the order that I saw them in. So, Florian,
Forgive
Michael,
me if I said anything that was
no. This is good.
Politically correct there.
This is perfect. You've clearly prompted a response that we're about to get. So, Florian, go ahead.
Yeah, no. So I think the short answer is that the way that reimbursement and the healthcare system is set up right now, in combination with the number of people affected, a lot of these applications, and ALS is just one of them, taken on their own, are there is no way from an emotional point of view, and I think we're trying to find ways by reducing the cost, but it's a combination of certain aspects not being deemed reimbursable. Those areas that are reimbursable having way too little funding associated with it, aspects that patients and their caretakers and families would agree are really important, seeing no value in terms of reimbursement or whatever. As long as that is the case, because we're unfortunately not in the 1960s where there was a little bit more of a Wild West, try it out, and if it helps, we go for it, but a very, very regulated industry and a reimbursement mechanism that is very constrained, that is very hard. Now, the paths out of that I see are strategies, and I assume they're not so different at Synchron, Precision, and elsewhere, is to say, if, however, I have a common platform that can be used across a number of different applications with minor changes, because the expensive part initially is the engineering, it goes into a lot of these aspects. And if I then, and that is an important question, find a way to keep the individual clinical trials manageable in terms of cost, then you can do a strategy where you go in and the low thousand numbers of ALS patients per year are justified because you add all these other ones, and it will take us 10 or 15 years to ramp that up. That is one component. We are committed, I'm personally committed to walk down that path. I will see these solutions out there, even though this is a painful path. Where I think we could help is if we merge that with impact investment, charitable work. I mean, if you look out there, there's stuff out there like ChatGPT, whatever, that has a for-profit section, but a major component that sees billions of dollars, that is just people getting excited about future opportunities. I mean, Microsoft invested $13 billion into that thing. I hope we can find a way to activate people to merge that. And then I do see it happening, but the traditional path of identify one large market with maybe a beachhead application will not work easily in the clinical field as it is. That's why we all need to work together. We need to educate the regulators, the reimbursement, and we need to have a strategy where to investors, we need to find the right ones that are willing to go that path where it's not one application. Now you've got millions of people that you supply with this. No, it's going to be small numbers. And I don't think actually that it'll be bad for everybody because we can slowly ramp up and learn. But I don't know, I'd be interested in other people's takes, but there's no silver bullet. Every application has challenges with it that would normally traditionally disqualify them for somebody to say, here's $150 million, go on and become the next Medtronic, which is unfortunate, but that should not stop us. Hasn't stopped us in the past. It's just to the 2023 America and society that is turned into something where unless there's $5 billion in market and massive numbers that can be reached, people won't touch it.
Florian, thanks for those perspectives. Michael, I'll let you jump back in, and then I think I saw that Nathan might have wanted to revise and extend his remarks, I think, but we'll let's head over to Michael.
Well, yeah, I mean, I think, Nathan, we're very happy to share our numbers in terms of sort of estimates of patient populations. I think it's not, I think you would come up with the same numbers and we all would. We're really looking at patients who are, unable to use their arms and hands, and in some cases unable to speak because of various, we call them subcortical paralyzing injuries, but spinal cord injury, certain kinds of stroke that leave cortex intact, and neurodegenerative diseases like ALS. And, I think, as Florian said, the patient populations here are small. That's just reality. And that doesn't mean that the human suffering isn't great and that the opportunity to do something incredibly impactful isn't tremendous. But just from a sort of business standpoint and commercial standpoint, the patient population that we're talking about is in the sort of 20,000-30,000 people per year, I think is our estimate. And obviously only a portion of those will elect to have an invasive surgery of some kind. So, for us, the key here in terms of, I think a lot of the questions that have been asked around patient access, around sustainable business models, around also seeing this technology, continue to evolve and develop, because, I think the prospects of BCI addressing all sorts of neurological illnesses are pretty considerable. It all comes down to reimbursement. I think, in order to create an industry that is viable, you need to pay a per device cost in the six figures. And when I say you need to pay, I don't think any individual is going to have to pay. At least in the United States, Medicare will pay. People who end up with these sort of injuries and diseases almost all end up on Medicare. So ultimately, this becomes really a societal choice. Where do we want to reimburse these devices that have the potential to be life-changing at a rate that will create a viable industry or not. And one of the interesting comparisons that we look at is the difference between how people think about reimbursement in medical devices versus in pharma, where in pharma it is normal to get a pill that or a treatment that extends life by a matter of months for an oncology patient, or that reduces symptoms of certain diseases by 20-30%. You get high six digits, and people don't think twice about that. But medical devices, which are considered sort of historically have been considered sort of different, I think have a completely different reimbursement and payment regime, which, especially when you're thinking about delivering treatment to, again, small patient populations, is a real hurdle for the industry to get over in order to create viability. And so, what I hope for, and part of, I think, the incredible work that organizations like this can do is really to help speak on our behalf, that to see technology like this widely dispersed will take reimbursement from private payers, but more importantly from Medicare and Medicaid in order to accomplish. And that's just, we decide, we're all voters, we all decide as a society what this sort of technology is worth. And I think the dollars and cents of it are just that, it's going to require a high reimbursement rate in order to create sustainability and then, future success in other disease states.
Thanks, Michael. Really important perspective. That is undoubtedly where the rubber hits the road. And on the way there, just as others were saying, we have to come up with the outcomes measures. We have to decide what they are. They have to be meaningful. And as you were saying, we have to do everything we can as our multiple communities and as a collaborative community ourselves to ensure that ultimately these devices will be reimbursed to the level that allows all of these companies to produce the devices that can do so much good.
And the companies, we're bad advocates for this because we're obviously self-interested. And so that just is what it is. No one's going to totally believe us. But that's why I think, all of the other stakeholders in this industry have such a powerful role to play in helping push the, critical nature of this technology and the difference it can make in people's lives.
Thanks. We're going to have two, I think, brief jump-ins here. I'm going to give Nathan a chance to revise and extend, and then over to Dan Rubin, and then we're going to hop over to Shel, who's going to who already has some questions from pals and others, and to hear from more of the group today. So Nathan, you've lost your screen. There you are. Go ahead.
Yeah,
there.
Thanks. No, I may have. I don't know if market research was really the right word to use, but I think research on what patient needs are really, and what I think a big question that I wonder is if we have a truly viable and accessible means of restoring or maintaining communication, will that change people's attitudes about ventilator support and end of life decisions? And I see some people reacting that that's a big question. I think and it's hard, maybe it's hard for people to even answer without knowing what they have available. I think we're sort of, and this is really historic. I think the what we've seen today on the videos, we didn't see that last year, and it's truly historic. I think it's a revolution, I think, right now. And I don't know, I'm really curious to know how people that are really faced with this situation day to day feel about that, and what does that mean to them.
Thanks, Nathan. And Dan, last word, and then we're going to transition over to Shel.
Oh, sure. I'll just to dovetail on what Michael and also what Nathan said too. I mean, in thinking about how to build a sustainable ecosystem for having these devices be funded and create a pathway for more people to get access to them, is thinking about all the things that communication gets you beyond being able to communicate with your family and your caregivers, is thinking about the impact of communication has on your health. being able to advocate for yourself, being able to describe your symptoms. I think it was Jonas, who's participant, mentioned that he was uncomfortable. That wasn't something that he could previously say. And so being able to describe if you've got earlier symptoms that prevents a hospitalization because you treat an infection sooner because you can describe it, or being a active participant in your own healthcare decisions, throughout, and being able to ask all the questions you want to ask in as much detail as you need, I think is going to improve health outcomes in a way that I think can really meaningfully impact the way that the people who end up paying for these devices may think about more benefits than just the communication at home, for example.
Thanks so much, Dan. So we're all here today to talk about devices that we are extremely confident are going to help people with ALS, are going to help the caregivers, care partners, people with ALS. And it is all of your insights that are by far the most important. It's what's driving the current research. It's what should drive the final version of a product that makes it to market. And Shel, I'm going to hand over to you. There have been lots of great questions in the chat and elsewhere, and I want to make sure we have plenty of time for those questions and to get the responses of our panelists.
Absolutely. Thank you, Leigh. Again, the last few minutes of this discussion has been extremely valuable and very on point. I kind of want to start off by reiterating a really important point, and that is that in this country, in the United States, only 10 to 15% of PALs opt for a trach, versus in Japan and some other countries, it's nearly 100%. This is something that's really, really important to keep in mind. And of course, that's not one single issue or one single driver that, that leads to that. Of course, one of them is financial, and how challenging and how financially debilitating ALS as a disease can be to the families, especially when 24/7 care is required once a trach is in place to take care of that person. However, the other point that we talked about in the last few minutes is quality of life issues. Do a lot of people living with ALS actually know that this is not just science fiction? This is truly happening, and it's happening effectively, and it can continue to happen effectively. So that brings me to some of the questions that the ALS community does have, and that is, as industry players as well as academicians, where are we with better access, better education, and better, communication about what is available, what is accessible, and how soon can this truly be accessible, if not from a, implantable perspective? Somebody else mentioned a low-tech perspective. How can we get the basic needs and necessities of people living with ALS met, so they can have the needed independence and also the needed, level of self-respect and dignity? So I'd like to kind of open it up with that. Where are we with that? How soon can we get that going if we all work together and are not continuously in the silos that, none of us want to be in?
Thanks, Shel. Lots of great questions in there. Let me look at our panelists, see if anybody wants to field that. If not, I will begin to call on folks. All right, let's put everybody on the spot. So industry representatives from Precision, BlackRock, Synchron, Paradromics, looking at various places on the screen. You've been asked when it will be available. So let's jump to the finish line. I know this is a hard question, so I'll back it off a little bit, but Shel knows it's a hard question too, and that's why she asked it. So please jump in.
Yeah, I'll jump in. I'll dive in first. And I think with everybody, there's always an uncertainty, right? Because our destiny is still guided, and we still have to work closely with the FDA and the regulating bodies. We've done our early feasibility trial, and next, and most likely with all of us, we're going to have to conduct a pivotal trial. Those pivotal trials, normally take at least a year, and that's probably pretty good if you're moving pretty fast to enroll patients and to work with patients. Then often these are class 3 medical devices, so there's at least a year follow-up. So and then there's looking at the results. So if you look at 2.5 years to be able to conduct that pivotal study, And that's really from point of when the FDA says go and to do the study. So you have to make it to that line of an IDE acceptance with the FDA, and then the green light goes, and then you start that piece. So so you're still looking, at least at a couple years, 2 or 3 years before I think there's a product on the market. Is my is kind of my forecast on that. But again, I think it takes at least that long, 2.5 years for once you get to that point of enrollment, you'll see the studies open up. So once you see those studies open up, that's kind of as fast as we can move from that standpoint.
Thanks, Kurt.
I'll state, speaking industry-wide, if that's good. Yeah, industry-wide, I think we're on a path to multiple options, whether they be part of clinical trial studies or all the way through PMA on the order of years, not decades. I think that is where things are vectoring. It obviously requires all of us working carefully, individually, and together.
Yeah, and I would add to that. I think Vikash is right. We're getting into clinical trials now across a number of different devices. In certain cases, it's already happened. In certain cases, it's happening in the next year or two. That is not going to necessarily mean very widespread adoption, but compared to the 60 some odd patients who've been implanted with BCIs over the course of the past 20 years, I think we're going to start to see that number start to increase very rapidly, not to where we all want it to be, but still relative to history, a lot faster. And then, I think for us, it's more widespread adoption, sort of the 4 to 5 year time frame from now.
Great.
If I can just hop in.
Daniel? Good.
Sure. I just wanted to highlight in the chat. I didn't realize he was going to be on this, but one of our participants has chimed in and just highlighted the impact that this technology's had on his life. And I think, looking at that comment in the chat and just highlighting that, and that's really powerful. And the users of this technology, the people who are benefit from it, can be incredibly impactful. And in the same way that patients have really pushed the FDA to move faster in pharma in so many fields, hearing voices like that and trying to bring them together to help bring these timelines down and move them from 2 years, 5 years down to 18 months or less, I think it'd be really powerful and really important to work on.
Yeah, so thank you for all of those feedback. I think it's really important, and another question that always comes up from the ALS community is, what can we do? What can the community do? What can the PALs and the CALs do to help industry and academics to really charge forward with this? And so a directed question would be, Michael, I think you spoke about this, that there's data that we need, right? We've all sort of collected data on what does the end user need, what do they want, what is the response, and how are things going with it? Well, is there a way to collaborate on that, to essentially create an open data area where we don't reinvent the wheel trying to collect this, and we actually have a compilation of the data and then move beyond that together as a team, as a collaboration? And how does that look from this perspective of both industry and academics? And how can the community truly help, which is targeted, efficient, and effective, so that we can get the reimbursements and the approval that we need?
Vikash, go ahead.
Yeah, so thank you for that question. I think one particular area that I think we all need to work together on is communicating where the field is and what is possible. Because even on the academic side, it is difficult enough to communicate with other experts and precisely describe where we're at. And you can imagine how much more challenging it becomes as we increase the scale of communication. And I think that communication effort needs to be done together with all of the stakeholders, so that we make sure that the communications are clear and accurate. And I think that can also help lead to further advocacy at multiple national and global scales that would help accelerate the field.
Gosh, Mariska?
Yeah, I think this is really important, and thank you, Shel, for confirming, for agreeing that data sharing is so important, because I think that in addition to that, if we have more insight for whom this is going to work and for whom it may not work that well, because that's one of the most urgent questions I think that we can answer with by data sharing. The other thing we really have to do, and I think that the ALS community can probably also play a big role in that, is for us to understand, but also for clinicians and neurologists to really understand the considerations towards tracheostomy and patient ventilation. And of course, part of it is financial, but that's probably not the only thing that plays a role. And how this would then relate to choosing for or against an implanted BCI, and also to discuss with ALS patients, their families, on the precise timing of these interventions. Do you take a trach first and then a BCI, or vice versa? What's the precise timing? What's the optimal trajectory for any ALS patients, in this treatment line? And I think for this community to really understand what the preferences are of the ALS community themselves, but also what is clinically manageable and feasible, what can be implemented in existing procedures internationally, not only in the US, but also Europe and Japan, because a lot of people there go in invasive ventilation. I think there the ALS community can really play a big role.
Yeah,
sure.
Thank you so much. Daniel?
Thanks. Just again, dovetailing off what Mariska was saying, I think one of the really important things is going to be making sure that there are multiple options out there, and advocating for the need for multiple solutions. There's not going to be a one size fits all, and different patients are going to have different preferences. Some people are going to opt for one sort of solution, knowing that there might be different risks and different potential benefits in terms of sort of, not to use bit rate, but that sort of idea, different capabilities of different systems. Some are going to be used 24/7, some might not have 24/7 capabilities yet, but understanding that there's going to be different options that are going to fit different people who have different people who have different needs, and having all of those options out there is, I think, going to speed up the development of all of them. We're all going to learn from each other, and more importantly, make sure that patients have what they need. There's not one cardiac pacemaker out there. There's not one prosthetic hip right there. There are many different options because every patient's different. And so I think it's going to be really important to foster this whole community.
Yeah, excellent point. Bikash?
Yeah, I was going to make at the risk of a concrete ask, right? That's always a dangerous thing to do. One thing I would love to see that I think could help the field is, Mariska had mentioned, I think you had mentioned a number of about 60 participants, right, across various studies, various technologies. And I think one thing we might all benefit from is some sort of meta-analysis, right? This would require colleagues really coming together to identify what each of these studies are, but not just kind of within the general perspective of each study, but really coming at it from the user perspective. What do these individual studies represent in this pathway towards the goal that we started to put together in some of the conversations here and elsewhere, right? Really focusing around the priorities of all of the stakeholders, the future users, but also their caregivers, to start to piece together, okay, where are we actually as a field, right? Is this a last mile problem, or are we further than that? But I think having an honest appraisal that also gives us a sense of where progress in the field has been as well, I think would help all practitioners and may also help us communicate beyond the stakeholders and practitioners here.
It's a great point, and I think it's a great ask. I love that you brought that up because, we don't get anything without asking for it, right? So, Mariska, thanks for bringing that up. And gosh, great ask, because I think all of us feel the same way. We need to know what worked, what didn't work, how did the end user feel, what was the result, what inspired them to joined this trial and how, what kinds of functions did actually improve. And are they still part of the trial? So there's a lot of key questions that I think we need to really get answers to. And again, it's all in the efforts to not reinvent the wheel, right? Let's see what we have right now and let's build upon it rather than go backwards and try to regain from the information that we should already have. That kind of leads me to the next question as well. We had somebody in the community ask, how are we actually integrating and collaborating to make the BCI technology and the information mainstream? And what I'd probably add to that is, let's kind of think about, multidisciplinary clinics that we have ALS multidisciplinary clinics, which we all know is a really effective way of treating people living with ALS. So if we have those, and we remember we've gone to multidisciplinary clinics and there is always, it's great. There is an OT, there's a, respiratory therapist, there's a speech therapist. That's great. How many speech therapists know what is available? What is out there with non-invasive BCI, with invasive BCI? What is the study that is happening now? What are the clinical trials available? Which one, why, when, to Mariska's point, at which step of the clinical picture are we going to need that, want that, or benefit from that? In addition to that, with mobility, right? With how many occupational therapists know what exists out there? So one of the, I'd love to hear comments on how do we educate the mainstream healthcare providers, the ones that are seeing the ALS patients. So I'll throw that out to you guys on how do we collaborate on that.
Shel, those are great questions. Am I allowed to respond?
Yes, Leigh.
I need permission, I think, in my role. Two quick thoughts. So one, referring to speech and language pathologist, it totally coincidentally on Saturday, I spent the day at ASHA, which is the American Society of Speech and Hearing. That is the Professional Society of Speech and Language Pathologists. That is one society that represents one really important group of clinicians, as you referred to. There are other societies that are the professional gatherings of the occupational therapists and the physical therapists, people who are the experts in the existing augmentative and assistive communication devices and who are providing what is available today and referring the right person to the right technology at the right time. So I agree completely that everybody on this call today and everybody that's logged in has an opportunity to contribute to that education progress, or progress and process locally and nationally. And I'll also just use this as an opportunity to encourage all of the pals and gals on this call to ask your neurologist about BCIs. And hopefully they will then provide you with a list of the ongoing BCI trials in your community. There is still a possibility that BCI will not be immediately meaningful to your neurologist or to who's ever providing your care, assistive device or otherwise. So please tell them that it stands for brain-computer interface and begin to provide the education, both what we can do as academics and from industry in getting the word out, but also from the people who we all hope will benefit from these devices in asking about them. And that is another, I think, powerful way to spread the word and to continue the education.
Thank you, Leigh. That's very, very insightful. Anybody else want to comment on that? Yeah, Jen.
I just want to say too, this is also, it's just incredible to hear all the different stories and about all of the different things that are going on. But I think, yeah, there's a big gap in mainstream, and use nonprofits. We're always looking for ways to help. This is all really, really great information that we would love to be able to share. If there are ways, or even if it's not packaged up neatly, but anything that we can share with the patient community, we would do that in a heartbeat. We would love that. So please always know that nonprofits are here to help, and just reach out.
Thank you, Jen. I think that's a great offer, and I agree. Second that, you have so much reach, and that would be a great project to undertake. David?
Hi,
You had your
thanks,
hand
Jen.
up.
Yes, thanks, Jen. And thanks, Jen. I was just going to say it's opportunities like this where I hope that we're really making, not only is it really great for us because we get to get feedback from the community that we need feedback from the most, but we hope that it's also, baby steps towards laying the groundwork for eventually when hopefully soon these types of products reach the market, there will be some awareness raised about what they can do and who they can help. And, for example, Pancho, he's part of another nonprofit group, Communication First, where they have it's just the amount of resources and the patient advocacy efforts that they do is it's really incredible, and we are really fortunate to be able to engage with them and with speech language pathologists and other medical societies. I mean, I hope that it goes a little bit the way of kind of like the cochlear implant, where eventually, well, I guess I don't know fully how it went from no one knowing about it to now everyone knows about it. Maybe that was a tumultuous journey, and if so, then I take it back. But I'm hoping that it's at least a good example that people can understand new, exciting technology, and hopefully it makes its way into its clinic to where it becomes really widespread and everyone understands the options around the technology and understands what it could mean to individuals.
Thank you. Very, very important comments. I want to just mention two things in case people haven't been following the chat. Just want to give a shout out to Casey and Emma, who have said that, they're so excited about the technology. They're in the BrainGate trial right now, and they just wanted everybody to know that, they can now speak with a conversation with their 5-year-old daughter or his wife and speak to friends. And he says it's one of the reasons that he's hopeful and will continue his work on climate change. So I think that should make all of you feel amazing because, it's really giving a lot of purpose to people who are in different trials. So this was, of course, BrainGate. Also want to mention Michelle Patrick, one of the attendees who said that actually she's the one that did the poster at SFN that showed the 60 participants. So I think that's really vital information. And Michelle, we'd love to hear more about that. And perhaps there's a link to the poster that you can share with us that we can then share with the community if you're open to doing that. We'd really love that. Would you like to say something, Michelle, if you'd like to say something about your poster, perhaps?
It's still in process. I've actually learned there's quite a few others that I didn't capture. I was looking at who had been published about. We are going to publish that information at the beginning of next year, but I'm happy to send what I have. I put my email address in the chat. I'm very much about collaborating, and shared knowledge is better knowledge. So thanks.
Thank you so much. Thank you. And thank you for letting us know about that. I'm sure all of us would love to hear about it. The other thing that has come up is patient advisory boards. And this is a really important point. We know a little bit about this personally because, since our foundation has been very involved with trying to push neurotechnology forward in any way that we can help, Zoe and I have both spoken to a lot of the industry leaders and some of the academic leaders about what do the pals, the people living with ALS and the caregivers, what do they want? What do they need? What are some really important elements of this? What I would also suggest is there are many of us that would, who would love to talk to everyone as a combined force, because why reinvent the wheel and do this 15 different times if we can all get together and really have certain pals and cows who are willing to be extremely open and honest and authentic about it. Let's get some shared, potentially patient advisory boards that share in BCI in general, rather than specific to each, company or academic institution. I'd love to share, get other people's input on that. Would that be helpful? Is that something that would mean something to whoever's on this call and the experts?
I mean,
anybody?
I'll just jump in. I don't have much to add other than to say that would be incredible. If there was a patient advisory board that was working with all of the academic groups and the industry groups, and was really just sort of plugged into what was going on. Invaluable.
Right. Anybody else from industry maybe?
No, I agree. Totally agree. I think it would be really, really helpful.
100% agree.
Mariska?
I switched microphones, so I hope you can hear me. I would love that idea. And if I can just suggest one thing, ensure that it's kind of a really international endeavor. So, you know, speaking on behalf of the Europeans in this call, I think, you know, we could use some patient advisory board recommendations in our part of the world. So that would be great.
Yeah. Wonderful. And yes, this is global, right? I mean, people living with ALS, I don't think that, you know, Americans have certain struggles, whereas people from other countries have others. This is a global issue. This is a global pain point. Communication and mobility is, you know, is the basic human need that we all need. And so, yes, I think that would be great. I would, you know, love to have further input. I'll put my email in the chat box, and ideas, input, and then someone's going to have to help put this together, and it's going to be, you know, Leigh, I'm going to look at you again as my co-host. But I think that people in the community would love to do whatever it takes to move this field forward, right? I mean, ultimately, we're here for the community, for the pals and the cows. That's why all of us are here. So I think that, you know, we'd be willing to, I know the community would be willing to do anything. Any other comments? I think that we are, Leigh, how are we doing with time? Do we have time for?
We do. We have time for, I'll just look at Jen, make sure I got a nod to, we've got time for one, maybe two more questions and feedback, and then we will wrap.
Okay. Okay. Great. Great. So one of the other questions that has come up is, you know, obviously with all of us, right? Money, financial obstacles, approval, CMS. I mean, all of that, we understand that there are true obstacles. And I loved what somebody said earlier, and this is, you know, in my entrepreneurial field, and all of us are entrepreneurial in our own way. I always ask, if money was never the issue, if you had unlimited funds, what do we need to do as a collaborative team of academics, industry, community, nonprofits? What can we do to expedite this field forward? And again, this is a very open question. If FDA approval was not a big issue, if money was not a big issue, how can we collaborate and push this field forward? Not, again, individual organizations have their own struggles, but, you know, we need to collaborate. So I'm going to open it up as a challenge. Something we're not doing, you know, something that we're not doing today, because as we all discussed, we've got 60 people so far with implantable devices, and we need to quadruple that in the next, you know, couple of years, we hope. So what can we do as a group? Don't everybody jump at once, please.
Well, one thing that I will mention is that for these implantable brain-computer interfaces, we're hopeful that just in the next few months, there will be kind of developed and formalized an opportunity for collaboration amongst all of the stakeholders on this call, and even broader, including people with cervical spinal cord injury or brainstem stroke and their caregivers and their care partners, to engage in broader collaborative conversations that will really identify some of these same issues that we're identifying today, and then to create work groups of people to think really carefully about them and to come up with consensus statements. So there's that sounds very meta, which I know, but in order to actually achieve these big goals across industries, across the different platforms that are being developed, to ensure that we're doing the right trials at the right time, and able to recruit the right people, and ultimately, when those trials are done, to be sure that they result not only in approvals, but in reimbursement, that is really going to be a team effort across everybody on this call and many additional groups and people. So look out for those opportunities. They will be appearing over the next few months, and just wanted to mention that.
No, that's great, Leigh. Thank you so much. Prakash, you have your hand up.
Yeah, so I was going to attempt a concrete around your question. And I think if we look at the way we currently run these studies, because they're early days, right, there's quite a bit of researcher involvement with each participant, which is wonderful. We're learning a lot from each participant. But this doesn't scale in two ways. One, the number of experts that are available, which maybe will grow as this ecosystem grows, but that takes time. And then the other way it doesn't scale is in understanding progress in the field. And I think it's the meta-study efforts that Michelle Patrick just mentioned that she engaged in. Those are wonderful, but the amount of effort to try to understand how these studies work together independently is tough. So in my mind, I would put that money towards reducing the number of researchers per participant that are required so that we can automate where we know we can automate, because there are, I think if we got a few of us in a room on the academic and industry side, we could probably agree on a handful of things that need to be simpler or more automated. I think that would really bring down the burden for each individual study and make it easier to look across studies to gauge progress as the field goes forward. Highly speculative, but that's my attempt.
No, great point. Great point. Mariska?
Yeah, one other thought I had, and I think in the BCI Society meeting in Brussels, I also brought it up. I think it's with the small studies that are currently going on, some of which and many of which are actually showing great progress in NS one or NS two studies. I think that we also have a need for not only showing the next improvement in accuracy and speed, but we also need to demonstrate, in larger communities or larger populations, just confirm existing, findings, things we have already shown, do exactly the same thing with a larger group, maybe outside of, the current industry efforts that are going on, but also within academia. And that requires dedicated academic funding instruments that are not only the high risk, high gain, but also that allow us to repeat findings and to delve into the depths of the factors that contribute if a BCI is working or not. So, calling NIH and other funding instruments or funding agencies for, specific grant instruments that would allow that kind of research, I think that will also help to move the field forward and to bring the technology faster to patients.
Absolutely. Couldn't agree more. David?
Yeah, I think this is a great question. And of course, it's in academia, things are fairly collaborative in terms of sharing of code and methods and publications. But I do think that overall, there's still going to be some things that will be, I guess, a little tricky to share. Like if, I don't know, I'm just thinking if companies or if anyone spends millions of dollars to create something, they may not be inclined to share it fully. I'm not trying to, this is just one thing that I imagine as maybe a challenge moving forward, but maybe all of the great companies here will prove me wrong. I hope so. But one thing that I do think can be really beyond not zero sum and just everyone can benefit is engagement with FDA and CMS and for reimbursement and regulatory approval, because I do think that we're at a very interesting and critical time in kind of the proliferation of BCIs and in kind of showing what's possible and expanding access. And the FDA seemed like, just given some of the presentation, they gave presentations at the BCI Society meeting, and it seems they really aren't, yes, the regulatory burden is very high, but it seems they're really not trying to slow down progress. and they're not trying to impose their own decisions and designs onto the field. It seems they really want to work closely with companies, with researchers, to move the field forward, but in a safe and regulated manner, of course. But so I think that is a way that everyone can benefit. I believe it was at a conference. Well, anyways, I feel like this group of people has talked about this before somewhere, maybe at this same symposium last year, but I think it's more true now than ever that we really can all benefit from maybe coming up with some kind of a joint strategy and best practices and things like this to really help us be consistent and clear with FDA and what we think would be most beneficial for patients, and of course getting the patient advice as well and all stakeholder inputs. I think it could help. Yeah.
Yeah, thank you. We've got a few more comments. Florian.
Thank you. Yeah, let me sort of go backwards and pick up where David commented on first before getting back to the other point as to what I think we can do. On the one hand, I'm grateful that sort of the FDA is actually showing that they're open-minded and that they want people to come together to discuss what outcomes are. At the same time, there is an element in there of trying to defer the decision and responsibility for where this is heading and moving into a process that could take years and years and years, because the reality is people right now don't fully know. And by bouncing the ball back and saying, you guys figure that out, instead of saying, you know what, we're willing to take a certain element of risk here and moving forward, they're saying, oh, we're not going to be in the way. You guys come up with proposals and then we'll think about them. I would wish there was a little bit more of a proactive stance to maybe provide some guardrails or allow areas to accelerate forward a little bit. You know, I do want us to have a voice in this. I think this is important. We will that together. I think we're all aligned in reimbursement and regulatory. Underneath that, we can have different technological approaches and compete for that. I think that can work. What really is important is spread the word and push for a broadening of the clinical indications. A point in case, there is an example of another area that was maybe not as interesting and impactful, nor, you know, in terms of what you're doing, emotionally sounding that strong, but, you know, bladder control, that is one of those areas where, you know, really, really important, not only for the geriatric population, but obviously a key problem to a lot of the sort of, there's an overlap with the population that we're dealing with. And originally, there were really only one or two solutions in that field. And it was an area that Medtronic was going to shut down because it was an unmitigated business disaster. Didn't work terribly well. And if you came to a clinician, they would have also, it was a last resort. If nothing else worked, then there's this obtuse bladder control device with a surgery that he could potentially go for. And nobody went for it. And then suddenly there were another 2 or 3 companies entering the marketplace, and the initial gut knee-jerk response was, let's shut it down, it's doomed. Now it's going to get even smaller. The opposite happened. Why? Because more people went out there to advertise for it. And now if you go to a doctor, it is no longer necessarily a last resort, but it's, okay, would you like the blue, the green, the red one, or the one with the stripes?
Yeah.
And pick one. Now, suddenly, it's no longer this oddball thing. And I think we're in a similar situation here, where if we can move forward and say, there are solutions out there. And it's no longer, there are people now who've lived with this for coming on to a decade with different versions. Right. Make people aware, increase the pressure on all levels, and sort of almost go into a bit of an advertising campaign. Of course, you want to have truth in advertising. Be careful to explain the risks and challenges associated with it. But there's a lot about, let's talk about, let's start making it a thing. There's a new set of therapies on the way, and that will start getting everything rolling together with encouraging regulators and reimbursement to look at it from another way without saying we want 10 years of studies before we can realize that comorbidities and other challenges from depression to obesity, whatever that comes with these diseases, is being addressed as well, and that has an impact on society and the cost. Sorry,
Right.
it was a short pitch, but I think this is really, really important, and encourage us as a nation to maybe have a little bit courage. As companies, we want to be very open and share the risks and challenges, but we're trying to get things to a point where there's zero risk.
Right. No, agree. I think all of those points that you made were really, really valid and very important, Florian. So thank you for doing that. I mean, that kind of is all about, we're going to have some takeaways from this. And Nathan, you have a brief comment. If you do, then please go ahead. We're going to wrap up right after that because we're getting some info from Jen that it's time.
I'll be very quick. I think what can be done, and especially PALS and their family, raise awareness amongst ALS, amongst neurologists that are treating patients with ALS, make sure they know about what's going on in BCI, make the ALS Association know about it, that interest in this, and that this is, the time has come. I think there's a lot of industry participation now. There's a ton of academic participation. I just don't think that everybody knows about it yet.
You're right. You're right. And I think, a couple of the takeaways that are educate the community, the regulators, the reimbursing organizations, CMS, nonprofits, and especially the mainstream healthcare practitioners, the neurologists, the multidisciplinary clinics, about BCI, all the different options, when, what, how, and what are the results of the 60 people or so that have had it so far. So again, that brings me to data sharing, to really look at what we've had so far and learn from it and build upon that rather than reinventing the wheel. The other thing we talked about was potentially creating an international joint patient advisory board that can serve all industry and academics across the board rather than, doing things individually. The next thing would be a potential, and I'm just throwing this out there, a quarterly meeting of, meeting of the minds of all the stakeholders, such as the ones that we have on this call, because it's only through us sharing the difficulties, challenges, as well as celebrating the wins that we can continue to move this field forward. And please make sure that, that we include the community so that you can really, really know what the end user is wanting from this. And then ultimately that's going to increase access and affordability and approval, and just for all the industry and academics to move forward. So those are going to be some of our takeaways. And Leigh, I'm sure you have more, but I'm going to pass it on for wrap up to you, my friend.
Well, thanks so much, Shel. I'll be second to last. I will hand back over to Jen in just a moment. But first, I'd like to thank everybody for participating today, both our presenters from academia and from industry, to Pat, to Zoe, to Casey and Emma, also thanks for joining in, and thanks for what was, at least for me, just a tremendous overview of the state of the field and a really rich discussion about both the incredible opportunities that brain-computer interfaces have to help people with ALS, to support the caregivers of people with ALS, and to really create a very, very bright future for restoring and maintaining communication for people with ALS and other forms of paralysis. It was a great discussion. It's one that I hope can and will continue. Thanks to Everything ALS and ALS Heroes, to the Healy Center, to ALS ONE for inviting all of us today to have this discussion. Thanks for the great feedback in the chat. I hope that you'll continue to provide this. From my standpoint, thanks to you for the opportunity to moderate today. I had a lot of fun. I learned a ton. And with that, I hope we get a chance to do this again. And I will, with my thanks, and on behalf of all of our panelists, thanks to everybody for joining in today. And Jen, I'll hand back to you for the last word.
Thank you so much, Leigh. You hear me? Am I not on mute? Okay.
We can hear you.
Leigh and Shel, I have to say, everyone, give a collective round of applause for the two of you for, working together. I know that this is, believe me, because I've worked on all 3 days, it's an undertaking. And all of you who have taken time out of your schedules, everyone's on different time zones. It's really important. But as I sit here and I see the registrations come through, and we had, close to 900 people register over the course of 3 days. The beauty of a virtual conference is that people can multitask and kind of come in and out. So you never kind of know who's exactly, listening in on each segment. But it would be really wonderful with, I don't know how you do this, but, we have one day for this, one day for that, and one day for neurotechnology. The morning, we're going to talk about this. The afternoon, we're going to talk about that. We need to all come together and really listen to what each other's going through. And again, I know time is not easy to come by. Life is very, very fast, but taking the time out for clinicians to hear about what you folks are all up to. I mean, this is so eye-opening and it's so important. As we work to lengthen the lifespan of people living with ALS, the quality of life is going to become more and more important. And what you are all working on towards that goal and towards that day, I just think everything we talked about here today with just mainstream media and just the mainstream ALS community as a whole, letting them know about that. I don't know if this is not to promote at all, this app or this organization, but they're fairly new and they seem to be doing a really great job. They're called Rune. And I don't know if that would be a great tool or avenue for you folks to listen in on and get in touch with them. And if anybody needs an introduction, I can certainly do that. But it's a really great new app that people with living with ALS, caregivers or pals can go on and ask questions. And I think adding a BCI segment to that would be really helpful for people to know what's going on. But again, I don't want to drone on. I just want to thank everyone for all the important work that you're doing and really being honest and open in sharing your views, because like it or not, some of them are tough and some of them are, you want to swallow a little bit before you answer, because you're not sure how they're going to be taken. But they're tough questions and a lot of them are tough answers. But when we all work together, great things are already happening. And thank you all for making that. But again, coming back to the nonprofit part, let us know how we can help. Let us know what we can do. That's why we're here. So thank you all so very much.
Thank you, Jen. Amazing, amazing job the last 3 days. Thank you, everybody. Have a wonderful, wonderful afternoon, and thank you for joining. Have a great one. Bye-bye.